Yep, let's start it. Now let's understand what is Kafka. So Kafka is a streaming and messaging framework. Kafka is a streaming and messaging framework. Apache Kafka is a software uh, software which is based on distributed streaming process. Kafka is a software based on distributed streaming process. Streaming process too. Kafka is a distributed streaming process. It is a publish and subscribe messaging system too. It is publish and subscribe, publish and subscribe messaging system. Publish and subscribe messaging system too. So by using this Kafka, applications can exchange data. Applications can exchange data between applications, servers, and processes. Kafka is a publish and subscribe messaging system. It can be used to exchange messages, exchange messages between application to application, or between applications, servers, and processes. So we can exchange messages between applications, servers, and processes team. So it's a messaging and streaming framework. It is a messaging plus streaming framework team. Apache Kafka is a messaging and streaming framework. It can be used to exchange data between application to application, or server to server, or process to process team. It is a publish and subscribe messaging system. Publish and subscribing messaging system team. Initially, it was developed by LinkedIn. Initially, it was developed by LinkedIn. Initially, it was developed by LinkedIn team. And later, they donated to Apache Software Foundation. Later, they donated to Apache Software Foundation. Apache maintains complete open source free software stream. Apache is one of the leading software company. It maintains all free and open source products. So these Facebook people donated this Kafka to Apache to make it as an open source and free team, to make this software available to everyone. LinkedIn people donated this software to Apache people. Okay, so currently Currently, it is maintained by, currently it is maintained, it is maintained by Confluent, Confluent under under Apache Software Foundation. Apache Software Foundation team. Under Apache Software Foundation, Confluent maintaining this Kafka software. Okay, so clear writing. What is Kafka? Now let's understand what is messaging system. What is messaging system team? So we understand what is Kafka, right? Kafka is a software. It is a distributed streaming process, and it is a publish subscribe mechanism, messaging system. It can be used to exchange data between applications. Maybe Java to Python, Java to Java, Python to Java, Python to Python, Java to Scala, Scala to Java, okay, Scala to Python, Python to Scala, like that. Exchanging data, exchanging messages between application to application, server to server, and process to process. Okay, so it's a distributed streaming process too. Initially, it was invented by LinkedIn. Currently, it is maintained by Confluent. LinkedIn given this software to Apache Software Foundation to make Kafka is a free and open source, because Apache Software Foundation maintains all free and open source projects. Free and open source projects too. Okay, so Kafka software is developed. Kafka Kafka software is implemented using Scala language team. Using Scala language. Kafka software is implemented using Scala language, and Scala is a JVM based language. Scala is a JVM. JVM stands for Java Virtual Machine. Java Virtual Machine team. JVM based language. So to run any Scala language applications, we need JVM. So to run Kafka software, we need Java. To run Kafka software, we need Java team. Kafka is a distributed streaming and messaging framework. Clear, right? What is Kafka? Yes or no? Team? Okay. Yep. Now let's understand the Kafka architecture team. In Kafka, only one daemon runs the team. In Kafka, only one daemon runs. Called server or broker. Server or broker team. So daemon means it's a background process. Daemon means it is a background process. Background process. Simply we can say it is a Scala program. It is a Scala program or Scala class. Scala class. So daemon is a background process. Once we start Kafka, it always runs in the background. Once we start Kafka, it always runs in the background team. Okay. So only one daemon in entire Kafka architecture is server or broker. Let's diagrammatically discuss team. In Kafka cluster, we can take one or more Kafka server or broker setting. We can take one or more Kafka servers or brokers. Server or broker. So we can take multiple servers or broker or single server or broker, depends upon our requirement. We can take n number of machines team. We can take n number of machines. There is no limit in Kafka architecture. We can take multiple machines. So server 1, server 2, server 3, server n. You can take n number of machines. So there is one more important component in Kafka architecture called zookeeper team. Zookeeper is a coordinator between different components in Kafka cluster. Zookeeper. And we have other producer. Other important component is producer. So we can take one or more producers. We can take one or more producer applications. So producers team. We can take one or more producer applications. Producer applications communicate with the zookeeper and understands the Kafka cluster. Then it interact with Kafka cluster team. Kafka cluster. There is one more important part is consumer team. So we can take one or more consumers. We can take one or more consumers. So let's say I have a consumer. So consumer first communicates with zookeeper. Then next it will communicate with Kafka cluster. So your consumer writes messages into Kafka team, Kafka cluster, writes messages into Kafka cluster. And sorry, producer writes messages into Kafka cluster, and consumer reads or consumes messages into consumes messages from Kafka cluster. So producer writes or produces team. Producer writes or produces messages into Kafka cluster. Okay. So this is Kafka architecture team. So in this Kafka developer works at writing producer applications or consumer applications too. Kafka developers works for writing either producer side or consumer side. developers works at producer side or consumer side. But coming to administrator works at Kafka setting Kafka cluster and creating topics, monitoring topics, and creating securities. Okay, so complete administration part of thing. So this part Kafka administrators works. Kafka administrators works in this part. So maybe one mission, maybe multiple missions. So here depends upon client requirement. As a Kafka administrator, we are going to set up complete Kafka environment. And depends upon the requirement, we will create a Kafka topics. We will create a Kafka topic. Okay, so we will create a Kafka topic thing. And we will create partitions. We will create partitions. We will create replications. And we will manage uh, topics are presented in Kafka or not. We will monitor Kafka topics. We will create securities. So lot of activities we are going to do as part of Kafka administration. So development side, developers may use Java or Scala or Python or maybe any programming language. But Kafka administration side, complete setups, configurations, monitoring, troubleshooting, performance, securities, upgradations. If there is any upgrade, we will upgrade. Okay, so clear writing. In Kafka, we have two types of people. One is developer. So developers works at producer side, producer side, or consumer side, consumer side, or both. They may use they may use Java or Scala or .NET or Python, or they may use any programming language for writing or developing Kafka producer applications and consumer applications. So coming to administrators, administrators are responsible for setting Kafka cluster, setup 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 Kafka cluster team, setup Kafka cluster, setup Kafka cluster, setup or install, setup or install, install Kafka, configure Kafka, configure Kafka, create topics, monitor Kafka cluster. If there is any problems, we will troubleshoot Kafka cluster, upgrade Kafka cluster, and providing security, etc. Okay, so developer purpose is complete writing producer applications and writing consumer applications, and to run this producer and consumer applications, they may use any environment, but final data stores in where either streaming or messages completely stores into Kafka cluster. So in this Kafka cluster, we will create a topic divided into multiple partitions. That concept we are going to discuss later. So mainly in Kafka we have two types of people: developers and administrators. Developers may uses any of these programming, but Kafka administrators, what they will do, they will set up Kafka cluster, they will add new missions, they will remove new missions from Kafka cluster, and they monitor Kafka topics, Kafka cluster, and next troubleshoot if there is any issues occurs, upgradations, security related things. Lot of activities we are going to do as part of Kafka administration, because Kafka is a streaming framework. I said it is a streaming framework. In for Kafka, producers continuously writes the data into Kafka. Yes or no? Producer applications continuously writes the data into Kafka. So Kafka should be up and run 24/7. Kafka cluster should be up and run 24/7. So Kafka administrators are mandatory. If Kafka cluster is down, producers cannot write or produce messages, and consumers cannot consume or reads messages from Kafka cluster. So Kafka cluster should be up and run, or topics should be available to producers or consumers, so that they can produce or they can consume. So administrators are mandatory for Kafka. Okay. So understand, right, team? Kafka architecture. Okay. Let's starting as part of Kafka administration. Let's understand Kafka setup on single node. Let's set up Kafka setup on single node team. So let's understand team. First, we need operating system. We need operating system. Kafka supports Windows operating system. Kafka supports Windows operating system, Linux operating system, and Unix operating system team. Kafka supports Windows, Linux, and Unix. Here we are going to use Linux operating system. In that, we are going to use CentOS operating system team. As part of our Kafka single node setup, we are going to use Linux operating system. In that Linux, we are going to use CentOS operating system team. Next, we need Java. We need Java. Recommended Java version is Java is Java 8 team, or latest version, later version. So Java 8 or latest version team. Recommended version is Java 8. And next one, Scala is optional. Scala is optional because Kafka software is implemented using Scala language. To run Scala applications, Java is enough. Okay. So Scala is optional. Next, Kafka latest version team. Kafka latest version. So these are required for set up or install Kafka team. It may be single node, it may be multi-node. We require these things. So let's diagrammatically discuss. So let's say this is my single mission. In this, first we need operating system. Next we need Java. Next to Kafka team. First operating system. So next Java. Java recommended version is Java 8. Java 8 is recommended. Next one, Kafka. So as part of our installation, we are going to set up all these components, all these concepts. Okay. Yeah. Yep. Next important one, Linux installation. In that first important point is Linux installation introduction. All Linux operating systems, comes into two flavors. One Red Hat based. Second one Debian based. Team. Red Hat based and Debian based. All Linux flavors comes into two flavors based on Red Hat based and Debian based. Red Hat based, we have Red Hat Enterprise Linux. Example, we have Red Hat Enterprise Linux. And we have Oracle Enterprise Linux. We have CentOS. There are many Red Hat based operating systems available in the market team. There are many Red Hat based operating systems available in the market. Similar way team, Debian also there are many flavors available. So first one Debian, next one Ubuntu, Kali Linux. There are plenty of Debian based operating systems are available team. So all flavors, all Linux operating systems comes into two flavors, so two syntactical styles, Red Hat based, Debian based. Okay. And the next important point, next important point, next important one, we can in Linux operating systems, Linux operating systems available in server based. So this one complete CUI means a command user interface. Command user interface team. So you can see only terminals. Command user interface, we can see only terminal. There is no graphical user interface. Next one we can see desktop. Desktop based. Then we can say these kind of systems GUI. GUI means graphical user interface. Graphical user interface. Graphical user interfaces like Windows operating system, we can see graphical user interface in desktop operating system setting. So Linux operating system, it may be Debian, it may be Red Hat, it may be CentOS, it may be Red Hat, it may be Oracle Enterprise, it may be Ubuntu. We get two kinds of operating systems, server and desktop. In server, we see only terminal. Desktop, we see graphical user interface. Okay. Yeah. Let's start it. In this session, we are going to see CentOS 7 server operating system. First one, step 1, download CentOS 7, CentOS 7 minimal ISO file. Minimal ISO file team. Minimal ISO file. It's around 900 MB plus. 900 MB plus. Software sizes around 900 MB plus. Second step, step 2, create a VM, virtual machine. Create a virtual machine. Second one, create a virtual machine. Step 3, configure virtual machine. Configure virtual machine. And step 4, install CentOS 7 server operating system. CentOS 7 server operating system thing. First, let's start downloading CentOS 7 minimal ISO files. First one, downloading CentOS 7 minimal ISO file team. Open any web browser. So I am opening here. Search CentOS 7 minimal ISO. CentOS 7 minimal ISO download. So here click on CentOS 7. So here we see CentOS 7. First link. So here it is showing CentOS 7 DVD ISO. DVD ISO is for server operating system, but we want minimal ISO file. In CentOS DVD ISO, we can select a minimal also team. In CentOS minimal DVD ISO contain both desktop plus minimal ISO. Or you can directly download minimal ISO. Click on second link. Here see CentOS 7. Click on download option. Okay, I have already downloaded. This is also server operating system because it is showing 4.5 GB. 4.5 GB means it's a server operating system. So minimal ISO file we require. Click on this one, second link. So here, so live CentOS 7, see 600 plus MB and 1 GB. So here we are seeing 600 MB. So minimal ISO. Click on this any of minimal ISO. I have already downloaded in my machine. I have already downloaded minimal ISO file. So this is 900 plus. Okay. Next one, create a virtual machine. Create a VM. Create a VM. So open Oracle Virtual Box. Open Oracle Virtual Box. Here we have an option, new button. Click on new button, or go to mission, click on new, or you can click on control N. Here enter CentOS. See, it automatically selected type is Linux and version automatically it is showing Red Hat based. Okay, CentOS 7 server. CentOS 7 server. So here it is going to install this CentOS 7 server in C folder, C drive. But I don't want to install in C drive. I want to install in different location. Click on this one, click on other, and click on destination location where you want to select. I want to install in F drive, under C family, under software, under VMs. Here I want to create a virtual machine. CentOS 7 server. So I selected CentOS 7. So create new folder, select this folder, then click on next. And here we are allocating RAM size. So CentOS server works on 1 GB RAM also, but here I am allocating 2 GB RAM. 2 GB RAM. RAM I am allocating 2 GB. Click on next. Choose default options. Choose default options. Choose default options. Here allocate RAM size for your CentOS 7, not RAM, hard disk size. So hard disk size I am allocating 30 GB. 30 GB for this virtual machine. Click on create. That's setting. Virtual machine is created. Next, configure virtual machine. Configure virtual machine team. This step is very, very important. Configure virtual machine. See team. Here, first one, we will attach ISO file. We will attach ISO file. Second one, we will select network type. Okay. Say team, your laptop or desktop connected with LAN card. Your laptop or desktop connected with LAN card. You are getting through internet through the LAN card. Assume you connected your desktop or laptop using LAN card. So through LAN card you are getting internet. Then network type is NAT. Choose network type NAT. If you are getting internet through Wi-Fi, then choose bridge adapter. Bridge adapter. Okay. So let's see these things in configuration team. So once virtual machine is created team, click on settings. Here general, this is our CentOS name. Click on advanced. It is showing where it is going to create snapshots. Description, I'm writing C family CentOS 7 server operating system. Then click on system. Here it is showing RAM. Next to click on processor, it is showing number of cores allocated to this operating system. My mission has a 4-core processor. It is allocated 1 CPU for this one. Next one, display. So I'm increasing this display sizes up to 150. Okay. Next one, storage. Here, select the ISO file. Click on empty. Here you see right side CD symbol. Click on here. Click on here. Choose downloaded server ISO file. So I want to add CentOS 7 minimal ISO. Select this ISO file. Click on open. Then audio network. So here I said, if you connected with LAN card, choose network type is NAT. In my mission, I am connected with Wi-Fi team. This is my Wi-Fi network. Wi-Fi network. So if it is a Wi-Fi, choose here bridge adapter. Okay. Click on OK. So configuration is completed. Then start installing. Install CentOS 7 server operating system. Install CentOS 7 server operating system. Select the operating system in a virtual machine, virtualization software. Select the operating system. Click on start. So here choose your operating system, CentOS 7. CentOS 7 minimal ISO. Click on start. So here press Control here and select install CentOS 7. Press enter. While installation, we do some operations team. Most of the options we will choose default options. Some options we are going to choose. Please see and choose same way. So default language, choose English. Click on continue. Click on continue. So here click on continue team. Click on continue. Here we are going to modify date and time. Click on date and time. Choose the region where you want to select the time zone. I'm selecting India. Next click on done. Next one, here we see installation destination. Click on installation destination. It is already selected. Click on one time. It is unchecked. Once again click on check. Click on done. So it is installation destination selected automatically. Next click on network and host. Here Ethernet card. Click on button. It will generate a dynamic IP address stream. Dynamic IP address is generated for our virtual machine. Here I am giving host name is C family. Host name is C family. Click on apply. Click on apply. Next one, click on done. Next one team, begin installation. Here we see begin installation. Click on begin installation. Here it is asking us to enter root password. I am entering root password is C family. C family. Once we enter root password, click done. Along with root user, I am creating one more user called C family. I am making this user as an admin user. I am making this user as an admin user, and password I am entering C family. Password I am entering C family. Click on done. Click on done. See team, around 299 packages are installing. If it is a desktop operating system, around 1000 plus packages it is going to install. Each package is a third party software. Okay, it may take a few minutes to install thing. It may take few minutes time team. Installation is successful. Click on reboot button. Click on reboot button. So it will restart the team. First time it will ask some options. One is accepting license agreement and some configuration settings. Next time onwards, it will not ask any settings team. Yep. So here it is showing direct to terminal. I said server operating system. Server operating system is completely command user interface. You will get only command user interface. So this is command user interface. Enter username. You can enter either root username or C family user. Enter password. So for root user, I given password is C family. For C family user, I given password is C family. ls pwd clear screen IP space addr space show. It will display IP address. IP address it is showing 127.0.0.1. It is a loopback address. Another one we are seeing 192.168.0.5. So here team, in server operating system, through Oracle VM VirtualBox, it is open another screen, right? This is not user friendly team. You cannot browse from any browser. You cannot copy and paste here. It is not allowed. So for that one, to resolve this one, we are going to use SSH client. I have a SSH client called Mobile Extem. So here we can create a connection. Here we can create a connection. Click on session. Click on session. Click on SSH. Enter IP address of your virtual machine. 192.168.0.5. Click on username. Which user you want? I want to C family user. Click on bookmarks. Give a name. I'm giving CentOS 7 server. Click on OK. Accept yes. Then enter password. C family. Then execute any Linux command type. Any Linux command. Okay. So that's it for CentOS 7 server installation. CentOS 7 server installation tip. Yeah. So we have successfully installed CentOS 7 server operating system. Now let's see connecting or create connection to CentOS 7 operating system. So why we need connecting? So when we start operating system, it will open Oracle VM window team.
This is Oracle VM VirtualBox window. Here we can connect operating system. We can access operating system. Okay, we can execute any Linux commands. But the problem with this Oracle VM VirtualBox window is we cannot copy from browser and we cannot paste here. So this is not user friendly team. This is not user friendly. So that's why we are using SSH clients to connect. So we will use SSH clients to connect VM. Okay, so we have putty mremote ng. We have mobile xterm. Lot of other SSH clients are available. So here I am using mobile xterm team. I have already installed mobile xterm. So now let's see, create a connection between mobile xterm and operating system. So here we have an option called session. Click on session. So in mobile xterm, click on session. Okay, so you will see SSH option. Click on SSH. Click on SSH. Click on SSH. Next one, here provide IP address. So my mission IP address we can find by using IP space A. So my mission IP address is 192.168.0.111. So enter IP address 192.168.0.111. So write that pointer thing. Click on SSH and then enter IP or host name. Let's say here 192.168.0.111. Next one, username optional. Username is optional thing. We have two users. One username is root and password is another username is C family, and for both users password is C family, and for this user also password is C family. So both are admin users. I recommend C family user. Team. C family user. Okay. So let's enter username, specify username, C family, and give a name to your virtual machine. Next one, give a name to your virtual machine. Give a name to virtual machine. So here we have an option, bookmark settings. Here it will take session name is IP address, username. So I'm giving Kafka single node. Okay, click on OK. That's the thing. It is connected. So if it is not connected, click on Kafka single node. It will ask a password. I already connected team. I already entered password. That's why it is not asking. For your case, uh, when you click on this Kafka single node, it will ask password. Okay, clear, right team? How to connect CentOS 7 operating system from SSH client. Okay, yeah. Now let's see Java installation team. Now let's see Java installation. Steps to install Java. Steps to install Java 8. Step 1 team. Step 1, download Java 8. Step 2, install Java 8. Step 3, set Java underscore home and path variable. Next, step 4, verify Java is installed or not. Java is installed or not. So first one, download Java 8 team. Download Java 8. So download Java 8 team. Open any web browser. Search Java 8 download. Java 8 download or JDK 8 download team. Java 8 download or JDK 8 download. So you will see Java SC download kit, Oracle website. Click on this one. This is actual download link team, official download link from Oracle website. So here you will see different operating system supported versions. You are going to see different operating systems supported versions: Linux, Unix, and Mac operating system and Windows operating system team. Okay, so here we need to download RPM, Linux x64 RPM. This is Linux x64 RPM. Click on this RPM file. Okay, accept license agreement, and here you will get link team. Copy link address. Okay, so we have to download this link address team. Okay, so we use wget command. So first we enter cd/opt. Next one, here we use sudo wget jdk url. We enter jdk url thing. So let's see sudo wget sudo wget and this path thing. Okay, so this is for accepting license agreement through the command prompt thing. So let's go operating system cd/opt. Now let's execute this command type. Sudo wget -c -header. Header is accepting license agreement, then URL which we copied. Enter password for C family user. So it is showing wget command is not found. So I am installing wget thing. Sudo yum install wget -y. -y we are giving confirmation while installing commands, wget command, it may ask multiple times confirmation. That's why I'm using -y means yes. Yep. So ls. Now let's execute wget command. So it is started downloading Java team. It will take few minutes. It depends upon our internet speed. Let's wait team. So once the download is completed, then we are going to install Java 8. Once download is completed, we are going to install Java 8 team. So we use command sudo yum install jdk and -y. Let's see team. Download is completed. ls. Okay. Now sudo yum install jdk -y. So this is the command team. So we are installing jdk -8u131 -linux rpm file. So installation is successful team. Once installation is successful, it will install under cd/usr/java jdk. This is the path team. So this is installation path. This is installation path. Okay, clear writing. Now let's understand set java underscore home and path variable. Set java underscore home and path variable team. Set java underscore home path variable. Why we need to set java underscore home? Why we need to set java underscore home? Java, by using Java, multiple softwares are implemented. Multiple softwares are implemented. Yes or no? All those softwares require Java home to run their software. So that's why we are setting Java underscore home. So when you install Java based software, it will refer Java underscore home to run their softwares. Okay. So Java underscore home, we set up to this path thing before bin. If you go bin, cd bin, here we have lot of Java commands. Java, Java C, Java H, Java P, jar command, various Java commands are presented. So why we need to set path variable? Why we need to set path variable? Why we need to set path variable thing? So path variable we set up to path variable we set up to bin path to bin. Why we need to set path variable? See, we have different commands here. To use these commands anywhere in our system, it may be root directory, it may be opt, it may be etc, it may be anywhere. To use these commands anywhere in our computer, we use set path variable thing. We set path variable. Okay. So now in Windows, in Windows, Windows, we use environment variable, environment variables, environment variables to set Java underscore home and path variable, Java underscore home and path variable thing. In Linux, we use profile files, profile files like dot bash rc, dot bash rc, dot profile, etc. to set path variable Java underscore home and path variable thing. Because profile files executes automatically, profile files executes automatically when user is logged in. So whatever we set inside profile files will automatically set to system. Okay. Now let's see the, now let's see setting up path variable, setting up Java underscore home path variable thing. So we go sudo, no sudo, nano tilde slash dot bash rc. Okay. Here we set up Java underscore home and path variable. So nano tilde slash dot bash rc. It's saying command not found. Now let's install sudo yum install nano hyphen y. Enter password of C family user. So it downloaded, installed successfully nano command. Now let's see nano tilde slash dot bash rc. Here as means comment team Java underscore home. Here I'm writing export Java underscore home equal to this path team, this path before bin directory, before bin directory thing. Next one, export path. Path already available in Linux operating system. So we want to add Java underscore home to existed path. So we use dollar path variable to read existed path, colon to concatenate new path. So dollar Java underscore home to access Java underscore variable slash bin. Bin contain all commands. Okay. So this path we are going to set Java underscore home and path variable thing in bash rc file. Okay. So control plus x plus y to save and quit from nano print, to save and quit from nano prompt, nano prompt thing, to save and quit from nano prompt. So control x y. Okay. I said profile files execute automatically when user is logged in team. So so we have to restart our system or we have to restart a bash rc file. So to restart a bash rc file, we use command source. So this one restarts bash rc file thing. Restart bash rc file. restart dot bash rc fine. So this is the command to restart it. Okay, clear, right? Now let's verify. Now let's verify Java is installed or not. Now let's verify Java is installed or not. So to verify Java is installed or not, we use Java space hyphen version command, or we use Java C command, or we use Java command team. Any of Java commands we can execute. Now let's see it. Java space hyphen version. It is showing Java version, Java 1.8.0. Next, Java C, Java command. So all commands are executing. Now we can confirm Java is successfully installed in our machine team. Clear, right? Okay. So that's it for Java installation team. Let's start in Kafka installation and configuration. First, let's see Kafka installation. Let's see Kafka installation team. Kafka is free and open source. Free and open source. So no need to pay single rupee for downloading and installing Kafka. And Kafka also provides a source code. If you want to customize, you can customize it. There are many third-party vendors providing enterprise version based on this Kafka open source. Okay. So we can steps to download Kafka team. Steps to install Kafka. Steps to install Kafka. First, step 1. Download Kafka. Download Kafka latest version. Latest version. Second one, step 2. Install Kafka. Install Kafka. Step 3. Set Kafka underscore home and path variable. Set Kafka underscore home path variable. Step 4. Verify Kafka is installed. Kafka is installed or not. Kafka is installed or not. So verify Kafka is installed or not. So first one more important to note to team. Before installing Kafka, make sure Java 8 is Java 8 or later version is installed in our machine. Okay, installed. Make sure Java 8 or latest version of Java is installed in our machine. Okay, in our server machine. So now let's see download Kafka latest version. Download Kafka latest version. So open any web browser. Open any web browser team. So I'm opening Google Chrome. search Apache mirrors. In Apache mirrors, we see first link. In first link, again, we see first link. Here we see all Apache products team. Control F, Kafka. So this is Kafka. Click on this Kafka. Here, latest version of Kafka is 2.8.0. At this point of time, latest version of Kafka is Kafka 2.8.0. Here it is supporting Kafka underscore 2.13.2 tar file and Kafka underscore 2.12-2.8.0. So this is Scala 2.12 supported. This is Scala 2.13 supported. Okay, so I am downloading Kafka 2.13-2.0. This is the tar file. Let's copy this one. Copy link address. So use command saying sudo. First, let's enter into cd/opt, and now sudo wget and this path team, link path. Now let's execute this command in our operating system, our Kafka single node operate mission. So cd/opt ls sudo wget and Kafka link tar file. Let's enter password of C family. Password is C family. It started downloading. It may take few minutes time. Depends upon our internet speed. Depends upon our internet speed. After downloading Kafka, then we will install Kafka team. Install Kafka. Installation means here we extract a tar file. This is the tar file team. This is tar file. So we extract a tar file team. We extract a tar file. So installation means first extract a tar file. Extract tar file. So we use extract to tar file, rename, remove tgz file, remove remove dot tgz file. It is optional. Next one, rename. Okay, this is also optional. So how we can extract a tar file? We use sudo tar -xvzf tar file name, tgz file. Okay, so once we got this one, then we remove this tgz file using command saying sudo rm-rf this tgz file. Next, we rename Kafka. This is lengthy name. So instead of this lengthy name, we use sudo mv this file name with Kafka. Okay, so in this way we will rename it. First, let's see. It's still downloading team. Let's wait few more minutes. After installation success, we are going to set Kafka underscore home and path variable. Kafka underscore home and path variable. Okay. So why we are setting Kafka underscore home and path variable. Why we are setting Kafka underscore home path variable? In Kafka in Kafka installation path, we have bin directory. It contain different startup and restart and stop scripts. To make these scripts available anywhere in our system, to make these commands anywhere, to make all these commands available anywhere in our system, we are setting Kafka underscore home and path variable team. Okay, so let's see. So it's almost download is completed team. Once the download is completed, we are going to perform this installation team. Yep. So download is completed team. ls. Here we use sudo tar -xvzf Kafka. Enter password of C family user. So it is downloaded successfully. So we used this command team. For extraction purpose, we use this command. And one more property also we set the team D. Change Kafka directory permissions. Okay, we'll see this one. Okay, change Kafka directory permissions. So first we extracted. So after extracting, we are getting this Kafka underscore 2.13-2.8.0. Okay, now rename or remove the star files. So sudo rm-rf star.tzz ls. Now rename. So sudo mv Kafka, and I want to give a name Kafka. Instead of this lengthy name, I'm giving Kafka ls. Now change file properties, change file permissions. Sudo chmod -R 777 on Kafka ls. So we changed permission stream. Okay, so let me take this one. These are different steps we have applied. Okay, so clear writing. Let me extract the command. Take this extract command. Yep. So these are different steps we have applied. Okay. So now let's do Kafka, set up Kafka home and path variable. First, let's see team, clear. CD Kafka ls. Here we have bin directory, config directory, lib directories, some other directories. CD bin ls. This bin contain different start and startup script setting. Start, stop, broker start, or broker or server start, consumer start, zookeeper start, etc. Okay. PWD. So this is our path. So initially we are in this location, then we move to Kafka. Okay. So now let's set Kafka underscore home thing. So we set under nano tilde slash dot bash rc file. Okay. So let's go nano tilde slash dot bash rc file. So let's set Kafka underscore home. As means comment team. Kafka underscore home. So first export Kafka underscore home equal to before bin directory team. Before bin directory. Before bin path. Okay. Next export path equal to first read existed path dollar path variable. Concatenate Kafka home until bin, because bin contain all Kafka commands. So dollar Kafka underscore home slash bin, so that all commands under bin directory available anywhere in our system. Okay. So control X Y to save and quit. So profile file executes after user logged in. Currently already user is logged in. So let's restart this profile file thing. So to restart this profile file, we use source command, source slash tilde slash dot bash rc. We use this command to restart bash rc file, so that whatever we configured in dot bash rc file set up to our system. Okay. So installation and downloading, installation and Kafka home and path variable is successfully completed. Now let's see command. You can take any command to test whether commands are working or not. I'm taking Kafka topic setting, Kafka topic dot sh. Let's go different directory instead of bin pwd. We are under slash home slash c family directory. I'm executing this command in Kafka topics dot sh. So it is asking some options. If we get a command not found means Kafka is not installed. Kafka is not installed. If you are getting options means Kafka related options means, then we can confirm Kafka is successfully installed. Kafka is successfully installed, team. Okay. So Kafka installation part is completed, team. Kafka installation part is completed. Clear, right? How to install Kafka? Okay. So we have successfully installed Kafka. Now let's see Kafka configuration, team. All configurations, configurations all configuration files presented in Kafka underscore home, in this we see configure directory, team. Conf directory. So Kafka cd/opt/Kafka. Here we see conf directory, team. cd config, not config directory. Okay. So these are different configuration files. We have first important file zookeeper.properties file. Next important file server.properties file. Next important file consumer.properties file. Next important file producer.properties file. Okay. So these are 4 important files. So first let's understand zookeeper.properties file. First let's understand zookeeper.properties file, team. By default Kafka comes inbuilt with zookeeper. Inbuilt with zookeeper, team. Zookeeper. We can also install zookeeper separately. We can use zookeeper. We can install separately. We can use team. Okay. So if you are using inbuilt zookeeper, means we have to do some modifications in zookeeper.properties. Okay. So here zookeeper has a default port is. So zookeeper, let's open zookeeper.properties file. Nano zookeeper.properties file. If you observe first important one, client port. This is the default port. First important one. So default port. Default port of zookeeper is 2181. 2181T. And next important one, we have to change data directory, team. So if you observe here, we are seeing data directory. So it is default, it is showing data directory temp location. So if you want to create temp location, okay. Otherwise you can specify different location. Okay. So in Linux environment, we have to create sudo mkdir and we have to create we have to create this directory team. So let me open duplicate tab. Then create this mkdir data directory. Okay. So create this directory team. Create this directory. I recommend change file permission also. I recommend sudo chmod 777 capital R 77 on this directory, zookeeper directory. Okay, so first one, data directory is mandated for zookeeper. Okay, so clear writing. So these are main changes we do as part of zookeeper team. As part of zookeeper. Next one team, server or broker. Next important one, server or broker. So we have server dot properties file. Server dot properties file team. Server dot properties. Server dot properties file. Server dot properties file. Okay. Let's see team. What are the changes we are going to do as part of server dot properties? Let's open server dot properties file. Control X, Y. So nano sudo nano server dot properties file. So first important one, sudo nano server dot properties file. First important one team, we have to give a port. So first important one, port equal to 9092 is a default port team. Every server contain broker ID. Every server contain broker ID. First important points. Every server or broker has unique ID. Every server or broker has unique ID. So this is unique ID team. And next important one, we have to provide zookeeper server location. So let's go scroll down. So you will see zookeeper.connect. So this is zookeeper.connect, and we have to provide zookeeper IP address. Zookeeper IP address. If we have a multiple zookeepers, then we give comma separation team like this. So servers we have multiple, then we give comma separation team. Okay. So next important one, data directory team. How we set up data directory for zookeeper? Same way, our Kafka also has logs directory. Let me see team. this is very important location. So all logs it will creates in this location thing. All logs for user it will create in this location. So logs directory we have to create. So let me create a logs directory team. So let's create this directory. So go to Linux environment. So sudo mkdir and create this directory team. Create this directory. So in other mission, I am creating this directory team. Next, change properties. Sudo chmod -r 777 on this logs directory. Okay. So next one team. Next one. Next one. Save this file. Save this file. Control X Y. Okay. So we given broker ID. We given port number. Okay. Then we created directory logs directory and we provided logs directory information. Okay. So these are important changes team. Next one. Next important one team. We have consumer file and we have producer file. So here no need to change anything if you are using inbuilt zookeeper. If you are using external zookeeper, we have to provide zookeeper information in consumer.property file, producer.property file. So one important note team, one important note. If you are using inbuilt zookeeper, if you are using inbuilt zookeeper, no need to change anything in consumer.properties and producer.properties. No need to change anything in consumer.properties and producer.properties file team. Okay. So clear, right team? So these are main configurations we do as part of a single node team. As part of single node, we do all these configurations team. Okay. Yeah. That's it for configuration of Kafka team. Okay. Yeah. Let's understand team. Kafka console producer and Kafka console consumer. Kafka console consumer. So we already discussed. We have in Kafka cluster we have server or broker. Yes or no? Next we have a producer applications and consumer applications. Producer and consumer applications we can implement by using Java language or Python language or Scala language. It supports many languages. Yes or no? So, so if you want to test writing messages into Kafka, we need to write a program. To test reading data from Kafka, we need to write a program. So instead of writing separate programs for writing messages and reading messages, Kafka people given console producer and console consumer applications. So Kafka console Kafka console, producer, and consumer are predefined applications. Predefined applications. These are predefined applications. Kafka console, producer, and consumer are predefined applications. For testing purpose, for testing purpose, or for practice purpose, practice purpose, Kafka people given these two applications. Kafka people given these two applications. These two applications. Kafka people given these two applications too. These are predefined applications. Kafka console producer. Kafka console producer can be used to write messages. Kafka console producer can be used to write messages. Write messages. And Kafka console consumer. Kafka console consumer can be used to read or consume messages. Read or consume messages team. Kafka console producer can be used to write or produce. Write or produce. Consumer can be used to read or consume messages. Okay. So these are two predefined applications. These are two predefined applications. So in Kafka installation path, we have two property files. In this location, we have two property files team. These are two predefined property files. These are two important predefined configuration files team. So if you want to perform any configuration related to consumer and producer, we are going to modify in this location team. So by default, Kafka comes with Zookeeper, inbuilt Zookeeper team. So instead of inbuilt Zookeeper, if you change Zookeeper or if you install Zookeeper in different machine, we have to provide that Zookeeper details in these two files. Because I said consumer and producer before consuming, before writing, it will communicate with Zookeeper. So Zookeeper information we have to provide in these two files. Zookeeper information we have to provide in these two files too. So let's see cat producer dot properties file, or let's say clear screen, sudo nano producer dot properties file, producer dot property file. If you scroll down, this one, bootstrap servers. Here we provide Kafka brokers information in producer dot property file. In producer dot property file, properties file, we change, sorry, In producer.properties file, we provide our Kafka servers. In our case, we have only one server. If it is multi-node cluster, we may have multiple server or brokers. So each server or broker information we separate with comma. We provide separation with comma team. Okay. If we have multiple servers or broker, we provide complete servers information in this location. Let's scroll down. We will discuss about max request size later, max buffer size, batch size. We'll discuss later team. Compression types. First to change, we have to do this server details team. If it is multiple servers, we separate with comma. You can provide all servers information in producer application, producer, console producer. Okay, similar way in consumer also team. In similar way in consumer dot properties file, control X. Let's see sudo nano consumer dot properties file. First important one, bootstrap servers. Next important one in this is group name, group ID. This is one more important property in properties file team. Group ID. Group.id test-consumer-group. So we will create a multiple groups team. So present we are adding our consumer into test.consumer-group. Later we are going to discuss very in depth about what is group and how we can create groups, how developers creates groups, and how developers adds groups consumers to group. Okay, so this is default group. If you want to change a group name, you can change here. Okay, so clear, right team? What are console producer and what are console consumers? Yep. So group here, let's say some consumers wants to read a topic, big data topic. We want to add multiple consumers to read the topic. So we create a group ID equal to big data. Then we will add all consumers in that big data group. Okay. Yeah. Now let's see first Kafka application. Kafka first application team. Console producer and console consumer. Kafka first application using Kafka console producer and Kafka console consumer. Kafka first application using Kafka console producer and Kafka console consumer team. First, let's understand steps to implement first Kafka application. First Kafka application or first Kafka example. First Kafka example team. Okay. So now let's see team. Step 1. Step 1, start Zookeeper. Step 2, start server. Start server or broker. Start server or broker. Step 3, create a topic. Create a topic. Create a topic. Step 4, write message. Write message into topic using console producer. Step 5, read or consume or read message from Kafka topic using console consumer team. So consume message from Kafka topic using console consumer. First one, start Zookeeper team. Start Zookeeper. Start Zookeeper. So to start any of Kafka related, we have all scripts in bin directory team. So ls pwd ls. So these are different script files. If you want to start a Kafka server or broker, Zookeeper, console consumer, and producer, and other creating topic related scripts, all script presented in this location thing. Okay, let me go here. So I'm coming from bin directory. Currently I'm in users home directory. So from anywhere we can start anything Kafka related, because we set Kafka underscore home path variable for Kafka. Okay, so clear, right team? So first one, we need Zookeeper script file. So syntax to start Zookeeper, syntax team, syntax. So Zookeeper hyphen server hyphen start. Zookeeper hyphen server hyphen start dot sh and Zookeeper property file. Zookeeper property file. Property file. So we have to pass Zookeeper property file thing. So let's see example. Let me start Zookeeper hyphen server hyphen start dot sh configuration file presented under OPT under Kafka under config Zookeeper dot property file. So this is Zookeeper startup script tip. Zookeeper startup script. So let's execute. So zookeeper is started successfully. Team. Zookeeper is started successfully. Next one. Start. Next one, start server or broker. Start server or broker. Start server or broker. Yep. Now let's see Kafka server or broker. So syntax, we have server script, Kafka hyphen server hyphen start, and we have to give path server underscore properties file path. Okay, so we have to provide Kafka hyphen server I underscore properties file team. Okay, so let's see example. Let's open new tab team, duplicate tab, clear screen. Kafka hyphen server hyphen start dot sh space slash opt slash Kafka slash config slash server dot properties. So this is the command we use for start server team. Start.sh. Okay, so we successfully started server or broker. Let's see team, 1 minute. It is giving error saying error exiting Kafka server ID 0 shutdown. So now let's see why this Kafka server is shut down. If you observe here it is giving error Kafka server ID 0, Kafka server startup shutdown. So here /temp /hyphen Kafka log recovery point offset checkout. Okay. So access denied for this location Kafka log. Let me take this one. Okay, let me change file permission team. Sudo chmod hyphen capital R 777 on this file, on this directory. Okay, once again let's execute Kafka hyphen server hyphen start.sh with this property file. So broker ID is 0. Broker ID is 0. Now we can say Kafka server started successfully. Yes or no? Kafka server started successfully. Team. Okay. So Kafka server started successfully. Now next important one, create a topic. Create a topic. Create a topic team. Yep. Create a topic. So here we have a script file for creating topic. Syntax for creating topic. So Kafka topics. Kafka topics dot sh create create topic topic name topic underscore name topic name partitions 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 number of partitions next replication factor replication factor and number of replicas okay. Next one zookeeper zookeeper and zookeeper list let's say localhost zookeeper in same machine, right? 2181 is zookeeper port number. If zookeeper running in different mission, we have to give zookeeper path. Okay, let's see example team. Let's see example. So I'm taking same command. I am opening new duplicate window. Yeah. So here first let's see topic name team. Topic name I'm writing C family underscore Kafka underscore admin. So yeah. So partitions. So here we have to use partitions team. So partitions. Number of partitions, I want to 3 partitions. Every topic divide into multiple partitions. Later we will discuss about what is partition. Okay. So here let me give create create topic partitions replication factor. Replication factor should be less than or equal to number of missions. How many missions we have? How many Kafka servers we have? Only one. So replication factor is number of replications are 1. Number of replications are 1. So this replication factor should be less than or equal to number of servers or broker missions in our cluster. In this case, we have only one server. So replication factor should be 1. Okay. So this is the statement to create a topic. Okay. So we successfully created. Let me execute. We this statement successfully creates. Yeah, we got one more issue because in zookeeper we have to give hyphen 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 hyphen. Now it will create them. See here, we got exception saying replication factor is not a recognized. Yeah, sorry. Replication hyphen factor, not underscore. Replication hyphen factor. So this one is replication hyphen factor. So topic is created successfully. So this is warning. Warning is not error. So topic is successfully created. So to know topic is created or not. To know topic is created or not. Topic is created or not. To know topic is created or not. So here we use command Kafka hyphen topics hyphen zookeeper Kafka hyphen topics hyphen zookeeper, then hyphen list. It will display list of topics presented in Kafka cluster. List of topics presented in Kafka topic team. Later we are going to see Kafka administration tools to manage these topics team, to create, to delete, to manage topics. We are going to use Kafka administration tools. Later we will discuss. At this point of time, we are using command to see the contents. Okay. Yep. So we successfully list of topics. So we started server, we started zookeeper. Okay. Now let's write a message using console producer. Let's write a message. Let's write a message. Let's write a message team. So we have a producer. Let me see. Kafka hyphen console hyphen producer. So let me write a message. So we start Kafka hyphen console hyphen producer dot sh file. Kafka hyphen console hyphen producer dot sh file. And before running this command, you make sure you configure this property. Make sure you configured this property. We have to provide bootstrap servers, means Kafka server information. Otherwise, producer application cannot recognize where is server. Okay. So let me execute this one.
So here it is giving this message. So you are typing Kafka and it is showing list of options. And in this list, we have to write a list of servers name, topic name, in which topic you want to write. So these are different options for Kafka console producer. One is brokers list, bootstrap servers list, and maximum block size. Later we are going to discuss all these things, team. Okay. So now let's execute Kafka console producer. Next one, hyphen broker hyphen list, hyphen broker hyphen list, and we have to provide brokers list, means a servers list team. We have only one server, right? That is localhost colon 9092 is a port number. 9092 is a port number. Then hyphen topic name, hyphen topic name, hyphen topic. What is our topic name? What is our topic name, team? So our topic name is big data, sorry, C family underscore Kafka underscore admin. This is our topic. Yes or no? Then press enter. So it is giving one more message saying, sorry, here we have to give hyphen topic team. Hyphen topic. So still it is giving message saying 1 minute. Did we give any mistake? So first Kafka hyphen console hyphen producer dot sh hyphen broker hyphen list. Let me see broker hyphen command. Hyphen broker hyphen list. There is one more hyphen bootstrap server. Yep. So only one difference here, not colon. We have to give space. Okay. So press enter. Now it is waiting for writing messages. I'm writing message. Welcome to C family. I'm writing one message. Okay. So let me take this one. So it's continuously wait for writing messages. Okay. Now let's see consume messages. Consume messages. Consume messages. Messages from topic using console consumer. Console consumer. Consume messages from Kafka console consumer. Yeah. So Kafka provides Kafka console consumer. So let's see example. So I'm writing example team. I'm opening another mission, new tab. So here I'm writing Kafka hyphen console hyphen consumer. Kafka hyphen console hyphen consumer dot sh hyphen bootstrap bootstrap hyphen server localhost colon 8
9092 9092 and topic name C family underscore Kafka underscore admin is our topic. Press enter. We are trying to read message from Kafka topic. We are trying to read messages from Kafka topic. See, here it is waiting. Let me write one more message here. Welcome to Kafka admin world. Admin world. Producer side we return message. Consumer side we got message. So previously we written one message. Just now we written one message. So in Kafka console consumer, we are getting latest message. Latest message. Let me copy this one. Let me copy this one. And understand team. Understand. Here it read latest message. Latest message. So if you want messages from beginning, then we use different option too. If you want a message from the beginning, we use different. Let me see. Let me stop this Kafka, Control C, clear screen. And here, hyphen from beginning. From beginning. From beginning. Yes or no? We are getting from beginning messages. How are you? Here we are getting messages. Yes or no? So if you want messages from the beginning, we use one more option called from beginning. Okay. So this is the command we are going to use. So understand, right team? How can we implement a console producer and console consumer application? Clear, right? Clear, right? Okay. Yep. In this session, we are going to see Kafka multiple or multi-node cluster or multiple broker setup. Multiple broker setup. Multi-broker or multiple brokers. Multi-broker setup on single machine team. Let's diagrammatically discuss. So we have one mission. In this mission, we want to start one zookeeper. We want to start one zookeeper. Okay. Then we want to start multiple brokers. So let's say I want to start 3 brokers with you. I want to start 3 broker or servers. Server or broker. multi-broker setup on single machine. Multi-broker setup on single machine team. So I want to start one zookeeper mission in same mission. Okay. So I want to start multiple server or brokers. Multi-broker setup on a single mission. Multi-broker setup on a single mission. We can start n number of brokers. We can start n number of brokers. Okay. This architecture or this approach only for practice purpose. It is never recommended for real-time purpose, because if one mission down, we cannot access topic data. Even though we have a multiple servers or brokers, we cannot access the data. Yes or no? Okay. So that's why this approach is not recommended. This is for practice purpose. This is for creating multiple replicas to a topic. Multiple replicas. Already we seen, we created a topic, we created only one replica. Replica should be less than or equal to number of missions in a cluster, number of server or broker missions in a cluster. In previous example, we have only one broker. In this example, we are creating multiple brokers. Broker 1, broker 2, broker 3. You can create any number of, but here we are using same mission, we are creating multiple brokers. So one important point, team, if you want to set up, set up multi-broker on single mission, multi-broker on single mission, we have to create a separate properties, a separate server dot properties, a separate server dot properties file for each server or broker. For each server or broker, we have to create a separate topic team. Sorry, separate properties file. Every server or broker, has unique ID. So ID should not be same for all servers. We already seen broker ID for server 1 is 0. So you cannot take 0 for server 2. You cannot take 0 for server 3. Server 2, you can take the unique ID. Server 3, you can take unique ID. Okay. In same mission, you have to run server or broker, you have to run server or broker on different port numbers, team. 9092 is a port number for server or broker. Yes or no? 9092 is a port number for server or broker. If you are running multiple servers or broker,
you cannot run multiple processes on a single port number. It is not possible. So you have to take a separate port number for each server or broker team. Clear, right? Okay. So let me do configuration team. We have already installed, installation is done in our single node mission. So we can use same installation, but only one thing, we are going to create a separate property file for each server or broker. Let me go. So create a separate property file for each server or broker. Create a separate server or properties file team, server dot property file. So let's create the team. cd slash opt slash kafka ls. Here we have a config cd config ls. Here we have server dot property file. I am copying cp server dot property file into server2 dot property file. Next, server3 dot property file. So first I have created two property files, two separate property files. Okay. So next one thing, next important point. Next one, configure server dot property file, server2 dot properties and server3 dot properties, server2 dot properties and server3 dot properties. Okay. So let's do team. So first I'm configuring server2 dot properties, sudo nano server2 dot properties. So first I'm configuring server2 dot properties. Sudo nano server2 dot properties. First I am changing broker id equal to 1 and port number equal to 9093. First I am changing these two properties. First I am changing these two properties. Along with this one, we have to change data directory path. Data directory path Kafka-logs2. So I am changing logs directory. Okay. So these are two changes for server2 dot properties. Similar way, server3 dot properties, in server3 broker id equal to 9094 and Kafka-logs is 3. Okay. So control X, Y, then change server3 properties file. Okay. So broker id equal to 2
broker ID equal to 2, 9094, and Kafka-logs, Kafka-logs 3. Okay, so Control X, Y to save and quit. Next, after changing this one, third important property, third important, create logs directories. Create logs directory for server 2 and server 3. Create logs directory for server 2 and server 3. So create a directory thing. Sudo mkdir Kafka-logs 2. Sudo mkdir /temp/Kafka-logs 3. So we have created successfully. Clear, right? How to set up multiple servers or brokers on single machine. Now let's see team. So we understand how to create multiple servers or brokers on a single machine, right? Clear, right? Clear, right team? Multi-server setup on single machine. Now let's start multiple servers. Now let's start multiple servers or brokers. Now let's start multiple servers or brokers team. Okay, so we already know how to start a server or broker. So first we have to start Zookeeper. Next we have to start server or broker. So this command is not changes team. Start Zookeeper. Start server or broker. So server 1, server dot properties, start server or brokers, servers or brokers. This is for server 1. and server 2 and server 3. Okay, first let's start server 1. Sorry, first let's start Zookeeper. CD, clear screen. Let's start Zookeeper. Let's open duplicate tab. Let's open duplicate tab. Let's open duplicate tab. Let's open duplicate tab. Okay, Zookeeper is successfully started. Now let's start server 1. Now let's start server 2. Before starting server 2, let me open duplicate tab. Let's change sudo chmod capital R 777 on /temp Kafka logs to Kafka logs 3t. Okay, so this is recommended. Change logs directory permissions. So now let's start. Now let's start server 2. So this is server 2. So Kafka server started, broker ID 1. This is Kafka server started, broker ID 0. Broker ID 0. Next, start Kafka server 3. Kafka server 3. So this is Kafka server ID 2. So all 3 servers are successfully running. Zookeeper is running. 3 Kafka servers or brokers are running successfully. Okay. So clear, right, team? Okay. Now let's see console producer and console consumer on multi-node Kafka console consumer and producer on multi-node team. Multi-node. So we started successfully Zookeeper and multiple servers we configured in a same machine. So here, first one, create a topic. create a topic. Create a topic with multiple replicas. Multiple replicas. Multiple replicas. Create a topic with multiple replicas. So we are going to see advantage of fault tolerance setting. If one topic is down, one mission is down, how it will resolve that issue, fault tolerance issue. How consumer can consume, how producer can produce. Okay. Yeah. So now let's create a topic. So creating topic team. Creating topic. Creating topic. Let's see creating topic team. So creating topic. Okay. Let's create a topic. Let's create a topic. Let's create a topic team. So Kafka topics created create topic name, let's say big data partitions, number of partitions I want, let's say 6 partitions, replication factor, I want to replication factor 3 replicas. Okay, each partition I want to 3 replicas. And zookeeper host name and port number team. So this is zookeeper related. Let me create this one team. So let me open, we have already opened another mission. Here I am executing this command. Yep, replication factor. Replication factor, replication factor. Replication factor team. Oh, sorry. Zookeeper. So this one. Zookeeper team. Okay. So we have created topic successfully. Now let's list the topic. So we use Kafka topics. We use Kafka topics list. Topics. So it will show previous topic as well as currently we created one topic, right? So we have big data topic. We have cfamily underscore Kafka admin topic. Big data topic just now we created. Yes, sir. Big data topic just now we created.
Now let's describe the topic theme. Let's describe the topic. Next important one, describe the topic. I want to know how many replicas presented for this topic. Describe the topic theme. Let's see team. Syntax is Kafka hyphen topics hyphen hyphen zookeeper host hyphen describe topic describe topic name. This command gives the old description of topic with the number of partitions, leaders, replicas, and ISR. ISR means in sync replica team. In sync replica. Let me execute this command team. Topic name, first I am giving C family hyphen Kafka hyphen admin. Here we have only one replica. Sorry. Kafka hyphen topics.sh. So if you observe, so we have three partitions, but replica is 0. 0 means number 0, 0, 1, 2. In sync replica, ISR means in sync replica also 0. Let's do same thing for big data topic. Let's do same thing for big data topic team. Observe big data topic. Observe big data topic. So if you observe big data topic, we have 6 partitions. Partition number 0, 1, 2, 3, 4, 5. 3 leaders 0, 1, 2, 3. We have 3 missions. Replicas. In sync replicas. In sync replicas too. So how many replicas are there? 3. 2, 0, 1. 0, 1, 2. Clear, right? So we described about big data topic. Okay. Now let's understand fault tolerance too. How multi server or broker achieves fault tolerance. Fault tolerance. How multi server or broker achieves fault tolerance. Okay. So first let's see producer and consumer team. So take producer and consumer. So take console producer. So topic name is big data. Topic name is big data and hyphen topic. Yeah. So let me take this one.
So in this mission, I am taking producer. The topic is big data. So you can take one server mission or multiple server missions. So welcome to multi-node cluster. Welcome to multi-node cluster. So here producer client ID console producer error while fetching metadata correlation ID 3 4 leader not available. So here before performing this one, let me open. Yeah, here you can write a message. Before that, let me open duplicate tab, clear screen, cd /opt / Kafka config. Here sudo nano producer.properties file, producer.properties file. In producer.properties file, here I want to add multiple server or broker missions details to it. Okay. So with comma separation, with comma, I want to add two more server details. Nine four 9393. Okay. So first one, add these details. So before producing, so let me control C, clear screen. So we added changes in producer. In producer, in producer.properties file, in producer.properties file, add below statement, add below statement or change below statement, change below statement. So we have this one to in this one. Okay. So in this way we have to change. Similar way, consumer also we have to do same thing too. In consumer also we have to do same thing. In consumer.property file. Property file we have to change in this way. Okay. So let's change control X, Y. Let's go consumer.properties. Okay. So let's change bootstrap servers, comma, 93, comma, 94. Okay. So control X, Y. Now produce message. Produce message. Welcome to multi-node cluster. Multi-node cluster on same mission. I'm writing message. Then consume message. Consume message. So our topic name is big data. Let's consume message team. Oh, sorry. So So let's open another window. Here, let's consume. Hi, let's wait. So first, let's see here. All servers are running. Producer return two messages. Consumer, let's see, control C. So process to 0 messages. Let's see 9092, comma, localhost colon 9093, comma, localhost colon 9094. Okay. So let's remove this hyphen hyphen beginning. Let's verify. Okay, let's write a message welcome. Let's write a message welcome. Yes, Tim. We resolved the issue by starting Kafka producer with all available servers. All available servers. So let's change producer start script with this approach Tim. Okay. So next consumer is same. Consumer also we started. So this is consumer script and we are receiving messages. Yes, sir. So next, let's understand how to how to achieve how to achieve fault tolerance. How to achieve fault tolerance. How to achieve fault tolerance. Even even or if any server is down, if any server is down, we can access data. Still we can access data. Let me stop server and check. I'm stopping server 3. Control C. verify, verify. Stop server 1, stop server 3, server 3, then write message, write message and check consumer is consumer and check consumer. So I'm stopping here. I stopped server 3. I'm writing message. Welcome to multi-node setup. Multi-node setup. We are getting coming to Kafka consumer. We are getting message. Yes or no? Let's stop once again. Producer, sir, consumer. Let's start consumer. You will get the messages from the beginning because we used hyphen from beginning. Yes or no? So we received messages. Yeah. So that's it for checking fault tolerance. Understand, right? Multi-node cluster setup on single machine. Clear, right? Okay. Yeah. So first let's prepare a virtual machine. We have already operating system. We have already operating system. Okay. We have already operating system. We have CentOS 8 server operating system team. We have CentOS 8 server operating system. So this is CentOS 8 server operating system. Okay, let me remove. So we have CentOS 8 server operating system. From this, what I'm doing, I'm creating one clone mission. Instead of applying all operations in this mission, what I'm doing, I'm creating clone team. So create clone. So let me create a clone for Kafka prerequisites. Kafka prerequisites. I'm creating one folder. Then click on other location. So go to F drive. Go to C family. Go to software. Under VMs team. Under VMs we have streaming. Let's say I am creating one virtual machine, Kafka prerequisites. I'm creating one virtual machine named Kafka prerequisites, and I'm creating this folder. So I'm creating a clone. Okay. So it may take few minutes. So from existed, create clone for Kafka prerequisites team. Kafka prerequisites. Kafka prerequisites. So it is created successfully. Let me go to settings. Let's change this name. Kafka prerequisites. So we created one clone mission. So in this clone mission, in this mission team, install Java, install Java 8, and next one, install Kafka without configuration, without configuration. Because if you configure, then it may, again we have to do configuration after fully distribution mode setup. Okay, so we have to modify a lot of things to avoid that one. So install Kafka without any configuration. Okay, so let me install Kafka team. Sorry, let's install Java. So we know how to install Java. So this is Java step. Yes, sir. Java installation. And after Java installation, set Java underscore home, restart bash RC. Verify Java is installed or not. First one team, we are installing Java. So let's download this RPM file. So first let's connect this virtual machine, start this virtual machine. Yep. So let's log into this mission, C family, and IP address of this mission is 192.168.1.22. Let's connect this virtual machine. So in mobile XTERM, I'm creating one folder team, Kafka MultiNode Cluster. Kafka MultiNode Cluster. Okay, in this first I am creating one new session. Click on SSH. IP address of this machine is 192.168.1.22. 192.168.1.22. And username is C family. And go to bookmarks, give a name to this virtual machine. So this virtual machine name is Kafka prerequisites. Yes, sir. No. Let me take name of this virtual machine. Kafka prerequisites. So let's take a name, bookmarks. Let's take a name, Kafka prerequisites machine. Click on OK. Then it is starting. Enter password. Okay. So clear screen. CD/opt Let's download this Java file. Let's download this RPM file. Enter password of C family user. So let's sudo yum install wget -y. Next, let's install Nano. We are going to use Nano for editing documents. So it is installed, team. Now let's download this Java RPM file. Yep. Now let's install sudo yum install Java RPM file. Yep, installation is completed. Now let's set up team Java underscore home path variable cd / usr Java JDK. So this is our Java path. So nano tilde / dot bash rc. Let's scroll down. Enter Java underscore home. Java underscore home. Export Java underscore home equal to this path. Next one, export path equal to $path colon $java underscore home / bin. So we set successfully Java path. Then restart this bash rc file. Source tilde dot bash rc. So we successfully restarted. Let's verify Java space hyphen version Java 1.8.0 underscore 131 Java C. It is working. Java command. It is also working. Then we can confirm Java is successfully installed in our mission. So first prerequisite is completed. First prerequisite is Java. Next prerequisite is Kafka without configuration. Okay. Now let's go Kafka. So Kafka is just installation team. Kafka installation. No need to do configuration. Configuration we are going to do later. So this is step 2. Next prerequisite is configuring Kafka team. Okay. let's do implementation team. So first go to Apache mirrors, find Kafka mirror, Control F Kafka. So go to this Kafka, and latest version of Kafka is 2.8.0, and in this tar file name is Kafka hyphen Kafka underscore 2.13 hyphen 2.8.o tar file. Copy this tar file link location, copy this link address, cd/opt sudo wget, paste this address string. So here let me clear the screen. Sudo wget, copy link address, okay, press enter. Then it will start downloading Kafka software. So it is completed team. Let's ls, okay, tar file sudo tar hyphen xv zdf Kafka tar command not found, sudo yum install tar hyphen y. Now let's execute tar command. So it is extracted. Let me remove unwanted files from opt directory. Sudo rm hyphen rf start.rpm start.tgz, clear screen, ls. We have Kafka. Let's rename this one. Sudo mv Kafka, this lengthy name with Kafka, clear screen, ls. Sudo chmod hyphen capital R 777, change file permissions on this directory because it is going to create some logs, right? So ls, permissions are changed. Now let's set Kafka underscore home path variable nano tilde slash dot bash rc. Let's scroll down. So Kafka underscore home, export Kafka underscore home equal to /opt/Kafka, export path variable equal to $path colon $Kafka underscore home slash bin. Okay, so control X Y. Then restart this bash rc file source. Now let's see, type any Kafka command. Kafka hyphen server hyphen start dot sh. So it is saying server dot properties is required. It giving some response. Kafka hyphen topics topics.sh. So it is asking some options. It means Kafka is installed successfully. Okay, path is set successfully. With this prerequisites are completed. So we are able to set up what prerequisite mission. So this prerequisite mission is completed. Okay. So now step 2, create a clone. So we completed successfully, prepare virtual mission with the prerequisites. Okay. Prepare a virtual machine with prerequisites. So this part is completed. Yep. So we successfully prepare virtual machine with the prerequisites. Yes or no? Now let's create a clone. Create a clone for Zookeeper, 3 server or broker missions, and 1 client mission. Create a clone for Zookeeper, 1 Zookeeper, 3 server or brokers, and 1 client mission. Create a clone. Create a clone for one Zookeeper, 3 server or broker mission. Create clone. So create clone for one Zookeeper, and 3 server or broker missions, and 1 client mission team. 1 client mission. Let's implement this one team. Let's implement this one. So go to Oracle VirtualBox. From prerequisites mission, right click on this one, click on clone. So if you want to create a clone, stop the virtual machine. Stop the virtual machine. So power of virtual machine. Okay. Now create clone for one Zookeeper. 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 Select the location. Other. Go to F drive. Go to C family. Software. Go to VMs. Streaming. Kafka. Sorry. Here I am creating one Zookeeper. Zookeeper. Let's select this one. So I am creating Zookeeper. Full clone. So once Zookeeper is created, create clone for server or broker. Server 1, server 2, server 3. Then create client. Zookeeper clone is completed. Now let's create one more, one for server 1. Server 1. Let's select the path, other, go to F drive, C family, software, VMs, streaming. Here create folder for server 1. Select this folder, full clone. Yep. Now create a server 2, clone for server 2. Go to other, F5, C family, software, VMs, streaming, folder, server 2. Select this folder. Here also give a name, server 2. Click on next, click on clone. Yep. Now let's create one more clone for server 3. Server 3. Select location of folder. So I'm selecting F drive, C family, software, VMs, streaming, create folder, server 3. Select this server 3. So name of virtual machine is server 3. Click on new, next, click on clone. Yep. So next create client machine. So client, okay, let's copy this one. Select the others, go to F drive, C family, software, VMs, streaming, create client, folder client, select this client folder, then next, full clone, click on clone. So we have Zookeeper, we have 3 servers, 1 client machine. So we successfully completed creating clone operation. Clear, right? Okay. Yep. As part of Kafka multi-node cluster setup, we have prepared prerequisite mission. We have created clone for Zookeeper, 3 server brokers, 1 client mission. Now, configuration team. Configure multi-node cluster. Configure multi-node cluster. Next important topic, configure multi-node cluster team. First one, Zookeeper configuration team. First one, Zookeeper configuration. Zookeeper configuration. Zookeeper configuration. So connect to Zookeeper mission. Connect to Zookeeper mission team. So start Zookeeper mission. Before that, I am going to change memories 2 GB team. System memory I am changing 2 GB because I have only 16 GB RAM. Okay, so let's click on this one. So similar way, let's change others. Instead of crash your system, let's reduce this one. Okay, let's start Zookeeper. Start Zookeeper. Start Zookeeper mission. Okay, so change Zookeeper dot properties file. Zookeeper dot properties file. So let's so it is started successfully. Let's connect to this mission team. Let's connect to this mission. C family. IP space A. So IP address of this machine is 192.168.1.24. So I'm creating session. So IP address is 192.168.1.24. Username is C family. Go to bookmarks. Here I am giving name is Zookeeper. C family. Clear screen. So CD /opt/kafka ls. Here we have config cd config ls. Here we have a zookeeper.properties sudo nano zookeeper.properties. So port number of this machine is 2181. So if you want to change any of these target directory, you can change, otherwise leave as it is. Okay, so create a logs directory. Create a log directory. So create this directory. Sudo mkdir. This is the directory, and sudo chmod -capital R 777 permission on /tmp/zookeeper. So we have successfully created a log directory for zookeeper, and we changed file permissions to that directory. So we successfully configure zookeeper team. We successfully configured zookeeper. Okay, yeah. Yep, we have seen zookeeper configuration, right? Now let's see server 1, server 2, and server 3 configuration. Server 3 configuration. We seen zookeeper configuration. Now let's see server 1, server 2, server 3 configuration. Okay, so now let's see it. So this is my server 1. Let's log into server 1 mission. C family. Now let's identify server 1 IP address. Clear screen. IP space A. So IP address of this mission is 22, 1.22. So let me create link here. Let me create a new session. SSH 192.168.1.22. Username is C family, and I am giving name to this one, server 1. Click on OK. It will ask password. Enter password. Okay, clear screen. So server 1 we connected. Let me connect to server 2. C family and C family. IP space A. So this is 13, 1.13. Let me create a connection. Create a new session. SSH 192.168.1. What is the IP address? 13. So 13 is IP address. So 13, 1.13. Username is C family. I am giving name to this mission is server 2. Okay. Enter password, C family, clear screen. So now let's connect to server 3, C family and C family, clear screen, IP space A. So this is 16. Let me create a connection, sessions, multi-node cluster, session, SSH, 192.168.1.16. Username is C family. And bookmarks, let's give a name, server 3. Password is C family. So we are able to connect 3 missions. So now let's start configuring. So for every server we have server.properties file. Okay, server.properties file type. So first one, server.properties file. Server.properties file. So in server 1 mission, server 1 mission. So I'm entering into server 1 mission. Server 1. Let's go cd /opt/kafka /config. Okay. So ls, here we have server.properties file. So sudo nano server.properties file. Enter password. So here first one team, broker ID 0. Next broker ID 0. Next one, port number equal to 9092. Port number I am giving 9092. So for this first mission, port number broker ID is 0. Port number is 9092. Next one, here log file location team. This is Kafka logs. Okay. So let me give a name, server 1. I'm giving log is server 1. So logs directory I'm giving server 1. Okay. So save and quit from this 1 minute. One more thing we have to modify, that is zookeeper IP address we have to change. Zookeeper IP address we have to change. So zookeeper presented in, tell me team, 192.168.1.24, right? It's 1.24. So let's change 1.24. So we have to change this IP address. Then finally control plus X plus Y. Okay, to save and quit. To save and quit. So same thing. Before, one more thing we have to implement, create a directory. So first one, modify properties file. Modify properties file. modify properties file, modify properties file, and create a logs directory. Create logs directory. So create this directory. Sudo mkdir this directory. Let me create this directory. Control X, Y. Let's create a directory. Enter password of C family user. So we created successfully. Change file permissions, directory permissions. Sudo chmod -r /temp server1 dot properties. Sorry. -r 777. I'm giving 777. So changing file permissions to changing file permissions. Change file permissions. Change file permissions. Okay. So these are the changes we do in server 1. Similar way, server 2. Do same changes in server 2 and server 3. Server 2 and server 3. Server 3. Okay. So let me do changes in server 2. cd/opt/kafka/config. And one more important note team. In server 1, server 2, broker ID I'm changing 1 and port number I'm changing 3. Okay, 9093. Server 3, broker ID 2, and port number 4. Okay, so let me do these changes. Sudo nano server dot properties and one more important point, log directory name here I'm giving server 3, log directory name here I'm giving server 2. Okay, so let me change here. So broker ID equal to 1 port equal to 9093. Let's scroll down. Logs directory name I'm giving server 2. The next one, zookeeper IP address is 192.168.1.24. Okay, control X, Y. Then next one, sudo, let me copy this command. Sudo mkdir, this is server 2. Okay, create a directory server 2. Okay, So let's create a directory server2. Let's change file permissions. Okay, we successfully modified server2. Similar way, let's do change in server3. Okay, so now let's see cd/opt/kafka/config. Here sudo nano server.properties file, enter password of C family user. Let's scroll down, broker ID equal to 2. Next one, port equal to 9094. Next coming to log file server3 coming to zookeeper. Let's change zookeeper IP address 192.168.1.24. Control X Y. Okay, so next one. So after creating this one, next one, create a directory server3 logs directory. Next one, change file permissions for server3 directory. So we changed file permissions too. So we created 4 missions, 1 zookeeper, 3 servers. Okay, so we did successfully configuration of servers. Configuration of servers too. Clear, right? So first one we did configuration of zookeeper. Next one we did configuration of server or broker. Okay, yeah. Yeah, next important one, client configuration team. Client configuration. So first one, uh, console producer configuration. Console producer configuration. Console producer configuration. So I have already opened the client machine. So let me create a connection. Create a connection for Kafka multi-node. So let me move this one to in this location. Let's create a connection to this machine SSH. Find IP address of client node, C family, IP space A, IP address is 17. So let me create 192.168.1.17. Username is C family. And coming to here, I'm giving name Kafka client. Kafka client. Okay. So click on OK. If you want to take 2 separate clients, one client for producer, one client for consumer, you can take, or you can use one client for running both. Okay, so you can take separate or you can take both. Here I am taking one client mission. I am using this client for producer, consumer, and Kafka topics creation. Okay, so instead of multiple missions, I am taking one mission. Yeah, so now producer configuration thing. So let's enter into cd/opt/kafka/config. Here we have producer file sudo nano producer.properties file, sudo nano producer.properties file. In this file team, first one, bootstrap servers. We have 3 bootstrap servers. Bootstrap servers means servers, Kafka servers. So we have 3 servers. Each server we can separate with comma. So first one, 192.168.1 dot server 1 IP address. Server 1 IP address is 22. Yes or no? 1.22. And port number is 9092, comma, server 2, server 3. Okay. So server 2 is 13. 13. So let me show. Server 2 is 13. Next to server 3 is 16. So let me enter. So port number of this one is 9093. This is 16. Server 3 IP address is 16. And one more important point to team. So here we are running server missions in different missions. Yes or no? Server demands in different missions. You can take port number 9092 in all the missions. For separating, for recognition purpose, I given different port number. You can take same port number for 3 separate missions. Okay. So first point, we have to change this one. Okay. Let's scroll down, team. Let's scroll down. So there is no other things. So clear, right? So we created Kafka producer configuration, Control X, Y. So to save and quit. After that, console, 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 consumer team, console, consumer. So consumer dot properties, consumer dot properties. Then same thing team. We have to change bootstrap servers details. So let's go sudo nano consumer dot property file. So let's change bootstrap server details. Along with this one, group ID. So group ID, instead of a test consumer group, what I'm giving C family group. C family group. So additionally, I am adding group name. So additionally, what I am doing, I am adding group name C family group. Clear, right? So we successfully configured consumer. So first one, producer. Second one, consumer configuration. Okay. Control X, Y to save and quit. Okay. LS. So we successfully configured mission stream. Okay. So we successfully configured producer. We successfully configured consumer. So client mission configuration is successful. Client mission configuration is successful. Clear, right? Okay. So configuration part is successful thing. So we have completed configuration of multi-node cluster. Multi-node cluster. Okay. Yeah. Yep. So we have completed multi-node cluster installation, and we have completed multi-node cluster setup. Yes, sir. So we have completed multi-node cluster installation as part of multi-node cluster setup team. As part of multi-node cluster setup. So we have completed multi-node cluster installation. We have completed multi-node cluster configuration. We have completed multi-node cluster configuration. Now let's implement it. Producer and consumer implementation on multi-node cluster. Next important topic team. Console, or instead console, let's say producer and consumer implementation. Producer and consumer implementation. Producer and consumer implementation on multi-node cluster. Implementation on multi-node cluster team. First one, create a topic. Create a topic. First important one, create a topic team. Okay, next one, produce messages. Produce messages. Third one, consume messages. Consume messages. So these are three steps we are going to do. So first one, producing messages team. Sorry, creating topic. Let me take first example. So first one, creating topic. Before creating topic, before doing these activities, first we have to start services. Yes or no? Start zookeeper. Start zookeeper. Zookeeper server. Next one, start three servers. Start three servers. Then create a topic. Okay. So first one, start server or broker. Start server or broker. Sorry, start zookeeper. First step we are doing zookeeper, and this is the command to run. Okay, let's go zookeeper mission. Let's start zookeeper. So we started Zookeeper successfully. Next, start server 1, server 2. To start server, we are going to use this command. Execute below command on all servers. Execute below command on all servers. Let me enter into server 1. Execute this command. Let's wait to start him. If you observe here, we are getting error. If you observe here, we are getting error. Yes or no? It is unable to connect the Zookeeper. So let me write that important point. Okay? Important to note. Okay? If you get error, for connecting Zookeeper, then make sure 2181 port is enabled. So 21 port is enabled. If it is not enabled, enable, we have to enable. This is our requirement. We have to enable it. Let me enable it. How to enable port in CentOS 8. It may be CentOS 8 or it may be CentOS 7. Process is same team. So open this Stack Overflow. Let's take this command team, firewall-cmd. So this is the command. Sudo firewall-cmd. Okay, next one. Sudo firewall-cmd -- reload. So your port number is 2181. Similar way, I also recommend execute this command. Enabling 9092. on server 1. On server 1. On server 1. This is on zookeeper mission. On zookeeper. On zookeeper. On server 1. On server 1. Next to same thing on server 2. Okay. So this is on server 2. So same thing on server 3. Server 2 port number is 9093. Server 3 port number is 9094. Okay. So let me execute this command. Let me execute this command on zookeeper mission. So this is my zookeeper mission. Control C. Clear the screen. Let me execute this command. Enter user password is C family. Next one. Restart this firewall. Sudo firewall -cmd. Oh, sorry. Hyphen. Okay. Go to server 1. Go to server 1. Execute this command. Here also we see hyphen. Okay. Next one. Reload command. Reload command. Okay. Next coming to server 2. This command is hyphen. Enter password of C family user. Next to reload command. Hyphen. Reload. Next execute on server 3. Hyphen. Execute this command on server 3. Next one thing. Hyphen reload. Okay. So we successfully did enabling port numbers. Okay. Now thing. Now let's start zookeeper. Now let's start server 1. This time we are not getting any error. Yes or no? Our server 1 successfully connecting to server or broker machine. Sorry, Zookeeper machine. So it is successfully connected with Zookeeper. So same command. Use same command kafka-server-start.sh and pass server properties file in a server 2 machine. So server 2 also started. Now let's execute server 3. Startup script on server 3. Server 3 also started. Zookeeper started. Server 1 started. Server 2 started. Server 3 started. Yes or no? So let me stop this server 1. Once again restart it. Once again let's start this server. So we have 3 servers. Yep. So we have 3 servers still. We have 3 servers. Now let's create a topic. Let's create a topic. Create a topic. So how do we create a topic? So we use Kafka-topics.sh command. Kafka-topics.sh command. Kafka-topics.sh. Here I am creating Kafka multinode. Kafka_multinode. Partitions 3. Replication factor, let's say 2. Replication factor is 2. Let's go in client mission. And in this first observe team, we are just typing this command, creating multi-node cluster, and topic name we are giving multi-node cluster, we are saying partitions, we are saying replication factor, zookeeper address we want to give here 192.168.168.1.24. So zookeeper details we are giving it. So let me execute this one. Could not execute. Okay. So period or underscore may not execute. Let's say Kafka multinode, then Kafka topics.sh create topic name partitions 3 replication factor 2 zookeeper details we provided. So topic is created successfully. We given Kafka multinode. So at this point of time, we are able to create, up to this part, we are able to create Kafka topic now. Now let's see writing messages. Too. So I'm opening separate mission to produce messages stream. Sorry, separate tab I am going to open. Let me open new tab. C family. In this tab, I am going to write a message. I am going to execute this one. Kafka multinode, right? Kafka multinode. So console producer I am taking. I am writing Kafka multinode. So let me, oh, sorry. Here we have to change 9092. 9092 is our server or broker machines. Let me take all these server or broker details. All three missions I am taking. Okay. So I'm giving with the separation while writing producing. Here I am using all server mission details. Then here hyphen topic. Okay. So let me execute this one. Let me execute this one thing. Clear screen. Let me execute. So it is waiting for writing messages. Welcome to multinode cluster setup. Welcome to multinode cluster setup. Okay. So maybe it's a warning. Let's wait. So let's open another tab, duplicate tab, enter C family user password, clear the screen. Let's write consuming messages from beginning. Consuming messages from beginning to. So I'm writing consuming message logic. Okay, here I'm giving complete bootstrap servers details. With comma separation. Okay, and topic name is Kafka multinode. Okay, let me take this command, execute in another client to tab mission. Okay, So here we are getting some error. Okay, let me check our server or broker measure. So broker 0, number of partitions 1, replication 1, and arguments Kafka icon ZK manager, invalid replication factor exception. Server 2 also we are getting issue, broker may not be available. So server 3 working fine. So let me stop this one. Let me stop this one. Okay, once again, let's start a server. Control Q. Let's start a server 2. Okay, so here we are getting some issue while producing messages. We will resolve this one thing. We will resolve this one in next session. Okay. Yeah. Yeah. So let's understand. In previous session, we got this. Yes, sir. So whenever we run, we got issue, got issue. Once we run producer and consumer, we got an issue. We got an issue. We got an issue. Once we run producer and consumer, we got an issue. Issue is servers, servers, servers failed to connect. Servers failed to connect, and consumer not able to consume, consume. Consumer not able to consume message. I resolved this. See, producer is able to produce. I welcome to welcome to multi-node cluster setup. Welcome to multi-node cluster setup. Consumer able to consume messages. Okay. So now we are able to access messages through the consumer, right? Producer able to write messages. Consumer is able to consume messages. Now let's understand how I resolved this issue. How I resolved issue.
First point. In server in three server in three server missions. I modified listener code, listener value. So let's see server one data properties, server data in server data properties. Okay, similar way server 2 and server 3. Let me take the server 1. Let me cancel this client. Okay, let me cancel consumer. Now I'm starting server 1. Okay, let me open server dot properties. I commented this one. First I commented this one. So first one I commented this one. Comment. Okay. Next one. Let's scroll down. Here I enabled this one with port number and host name. So listener port. So listener equal to plain text colon / IP address of host name of your computer colon 9092. This is in server 1. Similar way, server 2. In server 2, server dot properties file. In this, we commented this one 9093 we given right, and listener port we enable this one. What is our IP address of this one? 13, right? 13.9093. Coming to server 3. Server dot properties file. We commented this value and we enabled this and we added these entries 192.168.1.9 9094. Okay. So one more important to note here to segregate clearly, we used different port numbers for server 1, server 2, server 3. Okay. So understand that I resolved only by changing this value. By enabling this listener, then issue got resolved. And next one more point we have to no need to change anything in client, no need to change anything in consumer and producer. Zookeeper no need to change anything. Only 3 files we uncommented this listeners. Then we entered our host number, IP address or host name. That's it. Then we are able to produce messages through the producer. We are able to consume messages through the consumer. Okay. Clear writing? How to set up multi-node cluster? Yeah. Yeah. So let's understand. In previous session, we got this. Yes, sir. So whenever we run, we got issue. Once we producer and consumer. We got an issue. We got an issue. We got an issue. Once we run producer and consumer, we got an issue. Issue is servers 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 failed to connect. Servers failed to connect and consumer not able to consume consume consumer not able to consume message. I resolved this. See, producer is able to produce. Welcome to welcome to multi-node cluster setup. Welcome to multi-node cluster setup. Consumer able to consume messages. Okay. So now we are able to access messages through the consumer, right? Producer able to write messages. Consumer is able to consume messages. Now let's understand how I resolved this issue. How I resolved issue. First point. In server in three server missions. In three server missions, I modified listener code, listener value. So let's see server one data properties, server data in server data properties. Okay, similar way server 2 and server 3. Let me take the server 1. Let me cancel this client. Okay, let me cancel consumer. Now I'm starting server 1. Okay, let me open server.properties. Server.properties. I commented this one. First I commented this one. So first one, I commented this one. Comment. Okay, next one. Let's go down. Here, I enabled this one with port number and host name. So listener port. So listener equal to plain text colon / IP address of host name of your computer colon 9092. This is in server 1. Similar way, server 2. In server 2, server.properties file. In this, we commented this one, 9093 we given, right? And listener port we enable this one. What is our IP address of this one? 13, right? 13.9093. Coming to server 3. Coming to server 3, server.properties file, we commented this value and we enabled this and we added these entries 192.168.1.9 9094 9094. Okay. So one more important to note here to segregate clearly, we used different port numbers for server 1, server 2, server 3. Okay. So understand that I resolved only by changing this value. By enabling this listener, then issue got resolved. And next one more time, we have to no need to change anything in client, no need to change anything in consumer and producer. Zookeeper no need to change anything. Only 3 files we uncommented this listeners. Then we entered our host number, IP address or host name. That's it. Then we are able to produce. We are able to produce messages through the producer. We are able to consume messages through the consumer. Okay. Clear writing? How to set up multi-node cluster? Yeah. Let's start in configuring static IP address. Configuring static IP address. Okay. After previous session, I stopped all virtual machines. I started just now. There is no mission connecting. There is no mission connecting because at the time of installation of operating system, we choose an DHCP. DHCP generates dynamic IP address. DHCP generates dynamic IP address. So we choose an DHCP. It will generate dynamic IP. Dynamic IP address. Dynamic IP address string. So it will generate what? A dynamic IP address. So during multiple restarts, multiple restarts, there may be a change. There may be a chance of change of IP addresses. Change of IP addresses. So to resolve above problem, set static IP. Set static IP address. Set static IP address string. Set static IP address. There are many ways. There are many ways to set up static IP. There are many ways to set up static IP team. I'm using NMCLI, Network Manager Command Line Interface. NMCLI to configure static IP. There are multiple ways team. So I'm using NMCLI team. So first I am finding IP address of our mission. So first I am finding IP address of our mission. Let me log into this mission. C family. IP space A. We are getting IP addresses 192.168.0.7. So first one, I am applying zookeeper team, zookeeper mission, zookeeper mission. Same thing we apply for other missions also. Let's do change in zookeeper mission. So find IP. First one, step one, find IP. Find IP address. Find IP address. So here IP space A, we got IP address of zookeeper mission is 192.168.0.7. So let's say 192.168.0.7. Okay. So I'm connecting through SSH client. So let me close this one. Let's configure zookeeper. Edit session 0.0.7. This is my IP address. Click on OK. Now click on this zookeeper mission. Now it is able to connect. C family. Password is C family. So first we connected, we find IP address, we connected SSH. Now so to configure static IP, we use different ways. So first I am using sudo nm CLI connection. Sudo nm CLI connection. So nm CLI connection giving interface name is enp0s3. UUID is this one. Type is Ethernet. Device name is enp0s3. So we are getting UID, we are getting interface name. Okay. So nm CLI. nm CLI connection, it is giving interface details. Okay. So after this, let me execute nm CLI connection. We can use the nm CLI connection modify interface name IP address prefix. This is one way. Other way team, you can type nm CLI connection, nm CLI connection, nm CLI prefix. So let's say take this one. So our IP address is 0.7, right? 0.7. Next enp0s3. Correct name, right? Press enter. So next one, we used this command to change IP address. Okay. Let me take. This is the command to modify. Then after executing this command, again I am setting DNS for this CLI. DNS IP address. Why I am setting DNS IP address means to get internet for this mission. To get internet for this mission. So I'm using this one for setting IP to get internet for this mission. I'm setting DNS. Next one thing. So I'm executing this command to up this interface. Stop this interface, activate this interface. So that whatever the changes we are doing, right, it will reflect these changes in interface. It will reflect these changes in interface team. Okay. So next one team. Next one. After restart, then I am checking interface card details team. Whatever the changes we did, right, it will reflect in network scripts. IFCFG-ENP0S3 is a interface name. In this interface, it will reflect our changes. IP address is this one. DNS one is this one. Gateway also we have to give. Gateway also we have to give. Let's check gateway. So gateway we have to give them. This is the gateway. We have to give this command. Gateway number starts from 1. So this is for gateway. Gateway. IP address. IP address. Gateway. Gateway. DNS. 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 This one for to reflect the changes. To reflect changes. To reflect the changes. Then clear the screen to know the configuration of changes. To know the configuration of changes. To know the configuration changes. To know the configuration changes. Okay. So by using nmcli command, nmcli command, we are setting static IP address. There are multiple ways in we set up using nmcli. Do this configuration change for all other interface, all other servers. So server 1, server 2, and server 3. Do static IP change setup, static IP setup, static IP setup for server 1, server 2, server 1, server 2, server 3. Okay, same command. So first I am connecting server 1, C family, C family. Okay, IP space A. IP address of this machine is 06. Let me connect here. Okay, let me connect, change server IP. So this one is 06, 0.6. Click on OK. Click on server 1, C family. Then execute these commands too. Server 1. Server 1 IP address is 6. This is 6. Okay, let me execute this one. Let me execute this one too. Let me execute this command. Next, let me execute this command. So now let's check whether it is changed successfully or not. So it reflected successfully. Similar way, let's change it to server 2. Server 2. Let's change it to server 2 too. So find IP address of server 2, C family. C family. IP space A 0.8. So let's go SSH server 2 edit session 0.8 0.8. Click on OK. Click on OK. So now let's connect the server to C family. Clear the screen. Okay. So server 2 IP is 0.8. So let's take this one. Let's execute. Enter C family user password. Now let's take this one. Remaining no need to change. Execute. So DNS is gateway. We set a gateway. Next one DNS. Setting DNS. Next one starting interface. Next one find the configuration details of server 2 interface. So it is successfully changed. Do this for server 3. Do this for server 3. server 3. So find IP address of server 3. C family, IP space A, IP address is 9. IP address is 9. Only one value will change. Yes or no? So now let's create a connection to server 3, edit session 0.9, 0.9. Then click on this server, C family. Okay, so clear the screen. Now set a static IP. So go to execute this command. Enter C family user password. Now set gateway. Now set DNS. Start network interface. And change configuration of check configuration modified details. Details are updated or not. It is successfully updated. Okay. So next one. Setting static IP for client is optional. Client. Setting static IP. Setting static IP for client is optional. If you want to set, you can set, but it is optional thing. Because this is not a fixed client. This is only for our testing purpose. Yes or no? So client programs, producer and consumer programs may be developed in Java, may be developed in Python, may be developed in Scala language. It may be any programming language. Okay. So let me change it in first client C family, IP space A, IP address is 10. Client IP address is 10. So let me go sessions. Let me go client, edit a session. So here 0.10. Yes. Click on OK. Now let's click on client. Let's change changes of client team. Yes, connect. So enter IP address. So clear the screen. Clear the screen. Sorry. Let me once again check IP address of our mission. Client. Clear. IP space A. IP address of this mission is 10. Client mission IP address is 10. Okay. So let me restart this client mission thing. Same network, someone connected. That's why IP address is changed thing. So this mission is different mission. So let me close this one. Let's enter username, password. Now let's check IP space A. IP address is 10 only. Okay. So let me use these commands. Let me use this command. So I'm saving this 1 1 1 0 uh, 105. I'm giving 105. Let me execute this command. So sudo nm cli connection mod enp 0 s3 0s3 ipv4 dot address 192.168.0.105 /24. Enter C family password. So next one, unknown connection enp05. Sorry, 03. This is 03. Interface name is 03. Now NMCLI connection IPv4 dot gateway IP address starts from 1 0 1 0.1. Error failed to modify gateway. Yeah, so this one is not required. So it is successfully added. Now let's add DNS IPv4 dot DNS. DNS number is 8.8.8.8.8.8 to get internet. Now make this up. Sorry. Sudo nmcli connection of enp 0 s3. So connection is successfully activated. Now if you want to check this one, okay. Now let's check IP space A. IP address is 10. Still it is showing 10. Let me close this one. Let me restart once again.
Yep. Now let's log in C family, IP space A. Now it is still it's showing one. INET address is 105. This is INET address is 105T. We have two INET addresses. This is world one, this is new one. Okay. So through 105 we can access. So we can access client permission 105. So create a connection, edit. So 105. Click on OK. Connect the Kafka client. Okay. C family. And one more important point of view. Here I want to change this one IP address. IP address is 101 for Zookeeper. 101 for Zookeeper. 102 for server. 102 for server. Server 1. 103 for server 2. One zero three for server 2. 104 for server 3. 104 for server 3. Okay. Now once it is started, right, we have to up. Connection is disconnected. Okay, now let's go close this one, then make it up. Next, close this one, server 1, make this up. Okay, then Zookeeper, make this up. So we successfully set that. Yep, we successfully added static IP in all missions too. So Zookeeper 10 101, server 1 102, 102, server 2 103, 103, server 3 104, 104, and the client mission we given 105. Okay, so we successfully changed static IP. Yep. Okay. Yep. So in last session, what we did, we configured static IP. We configured static IP for Zookeeper. We configured static IP for server 1. We configured static IP for server 2, server 3, and client mission. Yes, sir. Sorry. So we configured static IP for all these missions. Next important point, configure static IP details in Kafka cluster. Kafka
cluster. Configure static IP details in Kafka cluster. One important point to think, did we change, did we given new IP, or did we use same IP for same IP? Did we use same IP or did we change different IP? Did we change different IP for static IP address, or did we use same IP? Did we converted DHCP IP to static IP? Which one we converted? Same DHCP IP, which is allocated for zookeeper, server 1, server 2, server 3. Same IPs we converted as static IPs, right? If it is not, then we have to update. We have to update zookeeper IP address in all worker missions. So zookeeper IP address is IP space A. IP address is 107. Zookeeper IP address. Let me connect Kafka server 1. Let me check server 1 IP address. Let's log in C family and C family. IP space A. So it is 109. 109. Server 1 IP address is server 1 IP address, it is showing 102. Let me take edit session. So we have 106. So what is the server IP we given? 102, right? 1 minute. 102 we given. Okay. Server 2 IP address. One zero two. Okay. Server 1 IP address 102. C family. Next one, server 2 address. Server 2 address we given 103. 101 for zookeeper. 101 for zookeeper. Okay. So 101 zookeeper is 101. Zookeeper is 101. Server 1 102. Next 103. Server 2 is 103. 103. Okay. Server 3 is 104. 104. Next, client mission IP address is 101. Yes or no? Sorry, 105. Okay. 105. Yep. Now let's do configuration team. We changed to static IP. Update instead of configure, let's say update static IP details in Kafka cluster. So in server 1, server.properties file. Server.properties file. In server 1, server.properties file. Let's go here. Server 1 sudo nano /opt /kafka /config server.properties file. Server.properties file. Let's change zookeeper IP address. Everything is same except this IP address, zookeeper IP address. So zookeeper IP address is 0.0.101. So this we have to update. Okay. So server 2, server 3 also same. Server 2, server 3 also same thing. Update our new IP address. Okay. Control X, Y. Let's go server 2 sudo nano /opt /kafka /config /server.properties C family. Let's scroll down. Yeah, one more thing we forgot. Listener port. Listener port also we have to change. Listener port. Listener port is 0.102. 0.102. Yes or no? Control X, Y. So for this one, 0.102. So this one, 103. This one, 104. 104. Okay. So let me go here, server 2. Server 2, let's change the listener port. 0.103. 103. Control X, Y. Next one. Oh, sorry. We have to change zookeeper also. Zero dot 101. 0.101. Control X, Y. Let's change server 3. Sudo nano /opt /kafka /config server.properties C family. Listener port is 0.104. 0.104. Next one. Next important one. Zookeeper IP address. 0.101. Control X, Y. So servers we have successfully configured. Now let's configure client. So let's go client configuration. Client CD. First one, we are using console producer, console consumer. So in client mission, in client, first file is producer.properties file. Producer.properties file. Sorry. So go to producer.property file, sudo nano /opt / kafka config producer.properties file. Under producer.properties file, we have to provide bootstrap server details. So this is 0.102. First bootstrap server is 0.102. Next one 0.103. 0.103. Next one 0.104. 0.104. Okay, so let's copy this property. Sorry, let's copy this change. Okay, similar way in consumer.properties also same. In consumer.properties. Let's go Control X, Y. Similar way, let's see consumer.properties. In consumer.properties, same thing. 0.102, 102, 0.103, 0.103, 0.104, 0.104. Control X, Y. So now cluster is successfully configured. So first what we did, we have successfully installed multi-node cluster. First one, what we did, we successfully installed multi-node cluster in virtual machines, virtualization. Next one, what we did, we set a static IP, because without a static IP, what will happen? Every restart IP address is changing. Maybe zookeeper IP, maybe server 1, maybe server 2, maybe server 3. IP address are changes because dynamic IP addresses. Dynamic IP addresses changing multiple times. So to resolve that one, what we did, we configured static IP. We configured static IP. Yes or no? We configured static IP. Then we updated the static IP information in all configuration files. In all configuration files, we updated this modification thing. We updated this configuration file, static IP details in all configurations, server, zookeeper no need to update, but zookeeper details we have to update in server 1, server 2, server 3. Next one, this listening port, we changed the listening port. And finally client, in client mission producer file, consumer file we modified. Okay, clear, right? Okay, now let's start and verify. Let's start Kafka multi-node cluster, Kafka multi-node cluster, and verify. Kafka multi-node cluster and verify. So start all services. Start all services. Okay. So first I am entering into zookeeper permission here. So cd zookeeper hyphen server hyphen start dot sh under opt under Kafka, okay, under Kafka under config zookeeper configuration file is available. We are passing zookeeper. So zookeeper is started successfully. Zookeeper is started successfully. Now let's start a server. Server Kafka hyphen server hyphen start dot sh slash opt slash Kafka slash config slash server dot properties file. So we are starting server 1. Server 1 also starting successful. Starting. So it is started successfully. Broker ID is 0. Okay. Now server 2. Kafka hyphen server hyphen start dot sh slash opt slash Kafka slash config slash server dot properties. Server 2 we are starting. So server 2 also started. Now Kafka hyphen server hyphen start dot sh slash opt slash Kafka slash config slash server dot properties. So all servers are successfully started. Now we can confirm our configurations are successfully working. Okay. So that's it for updating static IP details in Kafka cluster and starting Kafka cluster. Okay. Yeah. So let's starting as part of zookeeper. First, let's understand what is zookeeper. So first, Apache zookeeper is a open source. Apache zookeeper is a open source software. Apache zookeeper is a open source and free software. Yeah, free means no need to pay, no need to pay single rupee for licensing software. No need to pay single rupee for zookeeper software. Open source means they give complete source code team. They give us complete source code. According to our requirement, we can modify also. According to our requirement, we can modify also. So it's a centralized infrastructure and service. It provides centralized infrastructure and services that enables synchronization across multiple nodes. Main important of zookeeper is it provides centralized infrastructure and services centralized infrastructure and services that enables synchronization tool. Across multiple missions. Across multiple missions or nodes. Nodes in the cluster tool. Example Hadoop. First example is Hadoop cluster tool. Hadoop cluster. In Hadoop cluster, first main purpose of zookeeper role is high availability place. In high availability, we create multiple master demands. Like name node, we take multiple masters. Let's say one is active master and other one is passive master. One active master, one passive master team. Okay, active master and passive master. So we take one active, one passive master. If active master goes down, zookeeper updates this information to passive master, so that the passive master become active master. Passive master become active master team. Let's see. In Hadoop team, in Hadoop, let's say we have two name node missions. Name node 1 and name node 2. Name node 2. Here this is active. This is passive. And we have zookeeper mission team. We have a zookeeper mission. We have a zookeeper mission. Okay. So all the requests received by this active master. All request goes to this active master. Assume this active master is down. If this active master is down, then zookeeper updates this information to always zookeeper monitors this active master and this passive master. If it failed, it updates this information to passive master, so that it will become active master team. It will become active master team. This is one. Another one, Kafka messaging system team. In Kafka messaging system. In Kafka messaging system team. In Kafka messaging system, we have two servers. Let's say we have a 3 servers team. Server missions. We have server 1 and server 2, and server 3. So we have topic partition. Let's say this is partition. We have a 3 duplicate copies. 3 replicas we created. This is replica 1, replica 2, replica 3. So let's say partition 0, same partition 0. So this is partition 0. This one is a leader, and these two are followers. followers. Leader and follower. So if any request is coming, read request and write request. First it will write into leader. If leader is down, Kafka follows leader follower concept team. Kafka follows leader and follower concept. Leader and follower concept team. If leader downs, in these two missions, we want to make one mission as leader and other mission as follower. Which mission become a leader? Which mission become a follower? That voting concept is voting concept is performed by zookeeper and says first second mission is a follower, third mission is a leader. In a election, which mission become get selected, that mission act as a leader, other mission acts as a follower. Okay, so here zookeeper working as a coordinator between different components team. Zookeeper is a coordinator. Zookeeper is a coordinator between different components. Main purpose of zookeeper is synchronization team. Main purpose of zookeeper is synchronization. The main purpose of zookeeper is synchronizing information across the nodes in a cluster. Synchronization. Yep. Synchronizing information across nodes in a cluster. So zookeeper stores the information in memory or hard disk team. Zookeeper stores information in memory or hard disk team. It stores information in memory or hard disk. Next important point is zookeeper runs on Java. Zookeeper runs in Java and it works for both Java, Python, C language applications too. Zookeeper runs on Java. It supports Java, Python. It supports C APIs. C API or C languages. So it supports not only C, it supports many other languages also too. It supports many languages, synchronizing between different languages, different applications. Let's say diagrammatically discuss. So we have different applications. Application 1, Let's say we have application 1, and we have another application. We have another application. So here we have a zookeeper. We have a zookeeper. We have a zookeeper. So zookeeper is a central component, and it creates a coordination between different components. So middle, let's say this application is Java, this application is Python, this application is C language. Okay, middle we have API tool to synchronize between different applications. We have different APIs. We have Java API, we have Java API, we have Python API, we have C API. So we have different languages APIs too. To communicate with the different languages, we have a API. So from zookeeper, we can synchronize information to any of the application too. It may be Java, it may be Python, it may be C language. Any language synchronization we can perform by using zookeeper. So zookeeper maintains configuration and synchronization information in memory or disk or zookeeper server machine. So this synchronization configuration information, let's say coming to our Kafka. In Kafka, producer, consumer, we will give a zookeeper details. Yes or no? Zookeeper details. Yes or no? Zookeeper knows about complete servers and brokers details. Where it maintains? It maintains in memory or disk. Zookeeper maintains. Zookeeper maintains. Zookeeper maintains. Zookeeper maintains configuration or synchronization. Synchronization information. Configuration or synchronization information. Synchronization information in memory. In memory or disk memory. In memory or disk memory. In zookeeper machine too. In zookeeper machine. So if you remember, while configuring zookeeper, we created one temp directory, data directory in zookeeper.properties file. Yes or no? So there for complete information, it may be synchronization information. Okay, it may be configuration information. It stores either in memory means RAM memory, in memory means RAM memory, or disk memory. Disk memory means hard disk. Disk memory means hard disk. Okay. So next important point, zookeeper Zookeeper server mission. Zookeeper server is a mission which keeps copy of entire system. Example, in our Kafka, we have multiple servers and brokers. When server broker starts, whenever we start a server or broker, first it will, in server or broker properties file, we provide information of Zookeeper. So server or broker communicates with Zookeeper. Then Zookeeper maintains this or keeps this copy of entire server or broker information and synchronization. Let's say producer wants to write the data. So producer is a Python API. Then producer communicates with the Zookeeper and writes into Kafka server mission topics. Next, consumer. Consumer is, let's say, Java. Before writing data into Zookeeper, before getting data from server, it will communicate with Zookeeper to find the information of server. So Zookeeper server is a mission. Zookeeper server is a mission which keeps copy of entire system or configuration information or synchronization information. In a local log file. So it maintains complete configuration information into local log file. Next important point to think. 1 minute. Yes. So a large cluster supports multiple Zookeeper servers. A large cluster supports multiple Zookeeper servers. Multiple Zookeeper servers. I said one important point. We have in Kafka, we have leader and follower architecture. So Kafka follows leader and follower architecture. Okay. If leader fails, we have two followers. In the two followers, we want to make one as leader. So which mission we want to make it as leader? So for that one, Zookeeper performs polling operation. So in polling, in the two missions, which one elected as elected, then that mission become a leader. So to conduct polling, here we need, instead of taking one Zookeeper, if we take one Zookeeper, it gives priority to both followers, it gives same priority. It votes anyone. It will not vote two. Yes or no? If voting happens, if we have only one Zookeeper, it will vote to only one. Yes or no? So instead of voting only one, we will take multiple Zookeepers. So that which one gets more votes, that mission become a leader and remaining mission become a followers. Okay. So to conduct such kind of voting, then more Zookeepers are required. Okay. And in this scenario also, Here we are seeing only 3 applications. What if we have thousands of applications? Yes sir. What if we have thousands of missions, thousands of applications? So we want to synchronize with multiple applications. We want to synchronize with multiple applications. So we need more zookeeper missions too. We need more zookeeper missions. Okay. So let me understand you. Multiple zookeepers. So we take zookeeper server. Zookeeper. So we have multiple zookeepers. We have multiple zookeepers. Zookeeper follows leader and follower architecture team. Zookeeper follows leader and follower architecture. Zookeeper follows leader and follower architecture. Leader and follower architecture. So let's say here we have multiple missions. This mission is acting leader, remaining missions are followers. So we have multiple client missions. We have multiple client missions. So these are different client missions too. Client missions. Client missions. We have different client missions. So multiple client missions. So client may be Java, client may be Hadoop, client may be Python, client may be Kafka client. Client may be any client. So multiple client missions can communicate any one of zookeeper team, any one of zookeeper server. So multiple client missions, multiple client missions. Multiple client missions communicate multiple client missions communicate with zookeeper servers. Zookeeper servers. Multiple client missions communicates with the zookeeper server mission to achieve synchronization team. Synchronization. To achieve synchronization. So client may be anything. Client may be Java, client may be Python, client may be Hadoop, client may be Kafka, any client team. So clients, these are different clients. Clients communicate with server missions. Clients communicate with server missions. let's say this communicating with this server, this one communicating with this server. So this one communicating with this server, this one communicating with this server. So these two are communicating with this server. Okay. So in this way, communication happens to. So these are servers, server, server, server. So client, client. Clear writing. Let me take this architecture. So in large cluster environment, we take multiple zookeeper servers team. Okay. So next important, in zookeeper we see these are servers. Yes or no? So in zookeeper environment, in zookeeper, within zookeeper, within zookeeper, ये application, ये application or client mission, ये application or client mission. So this client may be application, this client may be this mission may be client mission or application team. Application means Java or Python or Scala. So applications also can communicate with the zookeeper for synchronization purpose. This is one. And missions, Hadoop missions, Kafka missions. So those missions, client missions are called Z node. Z node. Z node thing. Z node is a file that persists in memory. So Z node is a file. Z node is a file. Is a file that persists in memory. So Z node information persists in memory too. Okay, Z node stores the information which required or needs to be shared among multiple nodes in the cluster. Z node stores the information Yep. So Z node stores or persist. Z node stores or persist information which required or needs to be shared among multiple nodes team. Nodes in the cluster. Let's take zookeeper mission team. Let's take zookeeper mission. Let's say we have a zookeeper mission. This is our zookeeper mission. Zookeeper mission, and we have multiple clients. Application or client. Application in the sense Java, Python, .NET, or C language application, Scala language application. Client means Kafka software and Hadoop software, etc. So client softwares. So client mission or application. What these applications? These applications communicate with Zookeeper. Yes or no? These applications communicate with Zookeeper. Let's say we may have multiple applications or multiple client missions. We may have multiple client missions too. Okay, so all these client missions communicate with the Zookeeper mission. All these client missions communicate with Zookeeper mission too. Here, Zookeeper creates one file called ZNode. ZNode file too. In Zookeeper mission, it maintains ZNode. ZNode. It's a file. It's a file thing. Okay. Let me copy this diagram. So ZNode can be updated any node in the cluster. ZNode can be updated. ZNode can be updated any node in the cluster. Okay. So next one thing, any node in the cluster can make sure to be informed that changes to the ZNode. Any node. Let's say in Zookeeper server or cluster, in Kafka cluster, server or broker information we modified. Let's say previously we used DHCP IP, we changed static IP, and static IP is different static IP. So that configuration information, ZNode can update any node in the cluster. So this ZNode file can be update any node in the cluster. Assume you modified all server or broker missions configuration. That information automatically updated in ZNode file thing. So ZNode can be updated any node in the cluster. Any node in the cluster, any node in the cluster can make sure to be informed that changes to the ZNode. any mission, maybe all missions, maybe any one mission updates the cluster information to Znode file team. So let me see one diagram. So we have Zookeeper server or broker mission, Zookeeper server mission. In Zookeeper server mission, we have a Znode file. Zookeeper mission, we have a Znode file. Znode file thing. And we have clients, multiple clients. So client 1 and client N. So this is client 1. And this one is client N. Client N. So we have multiple client mission stream. So as a developer, so we are sitting here. So different node stream. Okay. So here as a developer or administrator, we updated configuration team. So in client mission, we updated configuration. First one, updating configuration. Updating configuration. Then this updated configuration information, other client wants to know. How other client know about this updated information? So first one, what we will do, from this client mission, it is going to update into, Znode file. So updates in Znode file. Second step, updates in Znode file. Znode file. Let's say team, here we want to update some information to client 10. My requirement is I want to update some configuration changes information to client N. So what I'm doing, I am updating configuration in my client mission. I may be developer, I may be administrator. I updated in client mission. So that change updates in client updates in Znode mission. From Znode mission, it goes to this client mission team. It goes to this client mission. It will synchronize update. Zookeeper synchronizes update. Third one, Zookeeper will synchronize update too. So that client N mission understands about Zookeeper update too. Client 10 knows update of client 1. Client 10 knows synchronization or update information of client 1. Okay. Clear, right team? Understand, right? What is zookeeper? Zookeeper is a coordinator. If you observe here, here we need to write one more important point. This is a zookeeper. Zookeeper mission. So in this two missions team, in this environment, if you observe, it coordinating client one information. Sorry, it's synchronizing client one information to client two or client n. Synchronizing client one information to client n. Okay, clear, right, team? Yep. Yeah. Zookeeper installation team. Steps to install Zookeeper. Steps to install Zookeeper team. Step 1. Step 1. Java first. Zookeeper supports. Zookeeper supports Windows or Linux. Windows or Linux. Zookeeper supports Windows or Linux. Here we are using Linux. Okay, and we have CentOS 8. CentOS 8 on Oracle VM VirtualBox. Oracle VM VirtualBox. Okay. Next step 2. Step 2 team. Java must be installed. Java must be installed. So recommended is Java 8. Java 8. Recommended version is Java 8 team. Next install Java. Step 3. Next one, install Zookeeper. Install Zookeeper. Install Zookeeper. So here we have two users. We have two users. User one is root and password is C family. User 2 is C family and password is C family. Password is C family. And this is main admin. This is Zookeeper admin team. Zookeeper admin user, I am using C family user as Zookeeper user admin. Okay. So this is my Windows operating system. This is my Windows operating system. Yep. In this we have Oracle VM VirtualBox. In this we have Oracle VM VirtualBox. Yeah, here I'm using, I created one VM. In this VM, I have installed CentOS 8. CentOS 8. In this, I have already installed Java 8. Java 8 too. I have already installed Java 8. Let me verify. So here, Java space hyphen version. We can see Java version 2. Java 1.8.0 underscore 131 means Java is installed in my machine too. Who do not know how to install CentOS operating system, who do not know how to install Oracle VM VirtualBox, how to install CentOS 8, how to install Java 8 on CentOS 8, we have one course team in cfamily.com. In cfamily.com, we have a course Oracle VM. Let's click on search Oracle VM VirtualBox. Click on search. Here you see Oracle VM VirtualBox. So at this point of time, it is free. So click on this Oracle VM VirtualBox and click on register. Then you will get in your purchase. Okay, here we have multiple topics team: VirtualBox introduction, VirtualBox installation, CentOS 8 server installation, CentOS 8 desktop installation. Okay, next how to connect SSH clients, and next one languages installation. Here we see Java 8 installation on CentOS 8. Okay, so follow this explanation and try to install Java on CentOS. Install CentOS operating system. Install CentOS operating system. After that, install Java 8. Okay. Yeah, this step 1 Windows virtual machine and CentOS server is already installed with these two users. And Java 8 step 2 also I have already installed. Then install Zookeeper. So these two steps already I have installed. Who do not know how to install, go to this Oracle VM virtualization course, mastering Oracle VM VirtualBox, and install Oracle VM VirtualBox, install CentOS server, then install Java 8 and CentOS 8. Okay. Yeah. Next, let's start installation of Zookeeper. Steps to install Zookeeper server. Zookeeper server. Steps to install Zookeeper server. Step 1. Download Zookeeper. download zookeeper, download zookeeper. Step 2, install zookeeper, Step 3, set zookeeper underscore home, and path variable, path variable. Step 4, configure zookeeper, Step 5, step 5, start zookeeper server, start zookeeper server, So these are 5 important steps, team. So first let's download zookeeper, team. Let's download zookeeper. Let's download zookeeper. Open any web browser. Search Apache Mirrors. Click on this first link. Here search zookeeper. Zookeeper. Here latest version is zookeeper 3.7.0. So this is zookeeper download link, team. Zookeeper download link. Okay. So here we see this tar file. Right click on this tar file, copy link address, then go to cd/opt, then sudo duplicate this path, team. Sudo duplicate this path. Let me execute this command. cd/opt ls. Here let's execute this command. Enter password of C family user. Depends upon your internet speed. It may take few minutes time. ls. It is downloaded tar file. Now install zookeeper. Install zookeeper means extract tar file, optionally remove tar file, rename extracted file. So extracting is nothing but installation, team. So let me do this activities, team. Clear the screen. ls sudo tar xvzdef tar file. So this is the command. Let's press enter. Clear screen. ls, then sudo rm-rf start.gz ls, tar file is removed. Instead of this lengthy name apache-zookeeper-3.7.0, we are renaming sudo mv apache zookeeper. Then I am giving short name is zookeeper ls, and sudo chmod -capital R 777 on zookeeper ls. So change file permissions team. Change file permissions. Change file permissions. Because runtime, it is going to create a log directory. So to create log files, it may get issue permission denied. So to resolve that one, it is recommended to change file permissions. So installation is completed. Now let's set zookeeper_home and path variable. Zookeeper_home path variable. Set zookeeper_home path variable. So first zookeeper_home we set before bin path to cd zookeeper ls. Here we set before bin path to path variable we set up to bin path to path variable we set up to bin path. Zookeeper_home we set before bin path. Okay, so let me set. Here we have one file nano _/.basrc _/.basrc. Every user contains some profile files. These profile files executes automatically when user is login. So we are setting zookeeper_home this variable so that whenever user login, this path automatically set to our Linux operating system. Okay, so let me set here nano _/.basrc. Here let's scroll down. Zookeeper. So export zookeeper_home equal to /opt/zookeeper. Export path equal to path already existed with some other path. We want to read existed path. For existed path, we want to concatenate zookeeper path. So colon is a concatenation operator. $zookeeper_home /bin. So this is the path we are setting zookeeper. These are the parameters too. Then control +X+Y to save and quit. Quit from nano. Quit from nano prompt. So let me execute control X, Y. Next, restart basrc file too. Restart basrc file. Why we are restarting basrc file? Why we are restarting basrc file? Because profile files executes at the time of user login. but already user is login, right? So to reflect our path, to reflect our path, to reflect our changes, we are restarting bash rc file. Clear, right? So now we can say installation is completed. Installation is completed. Next, we are going to do configuring zookeeper and starting zookeeper and verifying zookeeper. Step 6, verify zookeeper. Clear, right? We completed up to 3 steps. Okay. Yeah. Yeah. Let's continue it. So in previous session, we downloaded zookeeper. We installed zookeeper. We set zookeeper underscore home and path variable. Yes or no? Now let's configure zookeeper too. Let's do configuration of zookeeper. Yeah, configuration of zookeeper. So under zookeeper underscore home, under zookeeper underscore home, we can see config directory. Under config directory, we can see all configuration files. We can see all configuration files. Let me open configuration file. cd/opt/zookeeper ls. Here we have conf directory, cd conf. So directory name is conf t, conf. Under conf, we see configuration files. In this, yeah, in this we see zoo-sample.configuration file. In this, we can see zoo-configuration file. Okay, so here, let's copy this file. Let's rename to zoo.cfg, cp zoo sample.cfg to zoo.cfg, zoo.cfg. So first, not cd, cp, use cp. Okay, so once we rename, once we create a zoo.config, then edit this file too. So let's sudo nano zoo.cfg, zoo.cfg. In this file, we will perform configuration thing. In this file, we will do modifications. We will do modifications. Okay, we will do modifications. Yeah, in this file, we will do modifications too. So we will add like configurations like port number. We will configure We will configure port number, default port number is 2181. Next one, host name, here IP address we will provide. Next one, log directory or data directory and some other information thing. So these are main important configurations. Let's do modification in this file team. Let's open this file. Do.config file. Yeah. So if you observe here, tick time, unit limit, sync, data directory. First one, client port team, data directory and client port. So data directory, I want to create under OPT, under Zookeeper, sorry, under OPT, I want to create a data. Under data directory, I want to create OPT. So this path I want to provide, this path change I want to add in logs directory. Next one, client port number is 2181. Next one, see here, we didn't specify any host name. Default host name, it will take localhost. Default host name, it will take localhost 2. Okay, Control X, Y. Create directory, mkdir -p sudo mkdir -p under root, under opt, under data directory Zookeeper. So it is created successfully. Then let's change file permissions. Sudo chmod -R 777 on /opt/data. Okay. So we successfully configured and created required data directories. Now let's start it. Next important one, start Zookeeper. Start Zookeeper team. Start Zookeeper. So here we use in bin directory cd /bin directory ls. Here we have some commands to zk server .sh. This command can be used to start server. Can be used to start a server. Okay, let me start it. You can run this command from anywhere because we have set Zookeeper _home path variable zk server .sh and we can give start. So it is saying ZK server is started. So it is read ju.cfg file. Yes or no? Now ZK server dot status using conf zookeeper dot bin conf dot zookeeper client port found 2181 client address is localhost client SSL false error contacting service it probably not running. Okay, so let me restart. Stopping existed service and trying to start zookeeper server. Now let's execute server. Okay, let me go cd /opt /data directory sorry ls cd zookeeper ls. Yeah, I opened log file thing. I entered into opt directory, sorry, cd opt zookeeper, and I entered into logs directory. I uh, displayed this log. It is giving error saying could not found main class org.apache.zookeeper.server.quorum pair main. Let me take this one. Let's search. Let me check this one team. Process is running or not. C family zookeeper. Okay. So Apache zookeeper bin.tar. We have to download this one. Let me go Apache mirrors. Go to Apache mirrors. First link. Control F. Zookeeper. Zookeeper latest version. Here we have this bin.tar file. Copy link address. So team, we have to download. We downloaded tar file. So we have to download. We have to download this one. let me cd. First, let me stop zookeeper. Let me stop this service. Okay, now cd/opt ls. Okay, cd mv zookeeper underscore backup. Sudo mv zookeeper underscore backup. Okay, so now let's see sudo wget. This is the link. So let me copy link to. Let me copy link once again. Right click on this one, copy link address. Let me download this one. It may take few minutes time, depends upon your internet speed team. Yeah. So clear screen. ls sudo tar hyphen xvzdef xvzdef. Okay, let me remove sudo mv start.gz sudo mv and zookeeper sudo chmod hyphen capital R 77 on zookeeper. So clear screen. Then path we have already set. No need to do anything. Go to cd zookeeper /conf ls. Here sudo cp zookeeper.cfg to zoo.cfg. Okay, nano sudo nano zoo.cfg. Here let's change data directory path type. Let's change data directory path /opt/data/zookeeper. Remaining everything is same. Control X Y. Okay, we successfully configured. Now cd zk server.sh start. Now let's see status. Now it is saying zk server is successfully running. Client port found 2181. Client address is this one. Zookeeper JMX by default. Mode standalone. So it is started successfully. Only one thing we did, we have downloaded the star file. So recommended to download bin-tar.gz. So here they mentioned clearly. In Stack Overflow, they mentioned clearly. Okay. So successfully we started. Zookeeper is running in port number. Okay. So now, so this is the way to verify Zookeeper is running or not. So to verify Zookeeper is started or not, we use command zk server status, zk server.sh status. Clear writing? So that's it for Zookeeper installation on single node. That's it for Zookeeper installation on single node team. Okay. Yeah. Yeah. Let's start him. Kafka administration tools. There are many tools, team. There are many tools. There are many tools, many Kafka administration tools. First, let's understand the Kafka tool. Kafka tool. One important admin tool is Kafka admin tool. Let's understand the Kafka tool team. Kafka tool is a Kafka tool. Kafka tool is a free and free and open source team. Free and open source. It is free and open source. It can be used to manage Kafka cluster. We can say broker management. Broker broker management. Broker management tool. By using this Kafka tool, we can see topics. By using this tool, we can see topics, brokers, offsets, partitions. So brokers, we can see brokers, topics, offsets, partitions, consumers, producers, etc. We can see broker details, topic details, offset details, partition details, consumer details, producer details, etc. We can create a topics. We can create a topics. We can see messages. messages in topics, offset management, etc. So we can we can manage cluster, we can manage cluster, or we can do administration, we can do administration too. We can administrate, we can administrate, we can administrate cluster using this Kafka tool. Let's say team, let's diagrammatically discuss. So this is our Kafka tool team, Kafka tool. So this is our admin Windows machine. Windows admin machine. So this is Windows operating system. Windows operating system. This is administrator mission team. Let's say admin Kafka administrator mission. Kafka admin. Most of the time we have a uh, Windows missions team. Windows missions. So here we have installed Kafka tool. We have installed Kafka tool. Let's say we have installed Kafka tool. We have installed Kafka tool. We have local single node cluster. Let's say in our Windows mission, we have set up Kafka single node. Kafka single node. So Kafka single node. We have Kafka single node. And we have Kafka cluster. We have a Kafka cluster. Let's say we have Kafka cluster. We have a Kafka cluster too. Kafka cluster. This is on-premise. On-premise physical machines. We have same Kafka cluster in cloud. So we have a Kafka cluster in cloud team. Cloud may be any. Cloud may be AWS. Cloud may be Azure. Cloud may be GCP. Any cloud team. Any cloud. So we have a Kafka cluster.
we have a Kafka cluster. As a Kafka administrator, we are using this Kafka admin tool. As a Kafka administrator, we are using this Kafka administration tool. We are going to create a connection. So we are going to create a connection here. Local connection, local Kafka, on-premise, on-premise, premise, Kafka. I created a Kafka connections, cloud Kafka, cloud Kafka. So I created a connection, local connection. I created a connection, local connection. I created on-premise, on-premise connection. I created cloud connection. You can create any number of connections to any cluster. Any cluster you can create a connection to. Then you can monitor your cluster. You can create a topics. You can manage topics. You can see the partitions, offsets, brokers information. Everything you can see from this Kafka tool. It's a graphical user interface. Kafka tool is a graphical user interface team. Kafka tool is a graphical user interface. Kafka tool is a graphical user interface. Kafka tool is a graphical user interface team. So by using Kafka, we can create a connection. Okay. So this is Kafka tool. Okay. So clear, right? Clear, right? What is Kafka tool? What is Kafka tool? So understand, right, team? What is Kafka tool? Okay. Yep. Now let's see Kafka tool installation on Windows operating system team. First one, download Kafka tool. Download Kafka tool. Second one, install Kafka tool. Download Kafka tool and install Kafka tool. Open any web browser. Open any web browser team. So I am opening Google Chrome. Search Kafka tool, download, and first link Kafka tool, download Kafka tool. So they renamed it as Offset Explorer. Okay. So this is the link Kafka tool. This is official link to download Kafka team. Official link to download Kafka. So click on this. Here it is showing different operating system supported. Ours is Windows 64-bit. My machine is Windows 64-bit. Click on this download. Yes, I want to download it. You can download your specified location. So let's say I am downloading in other software's location under F drive, C family, other software location I'm downloading team. Let's open download location, F drive, C family, software, other softwares. Here I have downloaded Offset Explorer 64-bit. Double click on this Offset Explorer. Click on Yes button. Click on Next. Click on Accept License Agreement. Click on Next. So here it is installing Offset Explorer 2 in my F drive. So I want in C instead of C drive, I want in F drive. So I'm changing directory. Click on Next. Click on Next. So click on Finish button. So we successfully installed Kafka on Windows operating system team. We successfully installed Kafka on Windows operating system. So that's it for installation. Kafka tool installation is very easy. Okay. Yep. Next important one, Kafka connection team. So first I am showing Kafka single node connection team. Kafka single node connection. Connection creation is same for single node or multi-node. Kafka connection creation is same for single node and multi-node team. Okay. Yeah. Yep. First, let's see Kafka single node connection. Make sure Kafka running. Make sure Kafka running too. So here in Windows, we have F drive, C family, under software, under streaming, we have a Kafka. Okay. So we have already configuration files. We have server.properties. Let me open server.properties. So broker port number is 9092. Okay. So now let's start in. So we have under Kafka bin, we have first one Zookeeper Windows. Windows we have Zookeeper start command. Zookeeper start command. Let's say CMD. And one more important point, you can execute these commands from anywhere because we already configured Kafka home. So Zookeeper start and property file location. So property file is property file location is this one. This is the path. So zookeeper.property file / zookeeper.properties. Zookeeper is starting team. After that again, I'm going to run Kafka server team. Go to bin, here Windows, Kafka-server.start. Kafka-server.start file. Let's open Kafka-server.start and pass /server.properties file. Server.properties file. So both zookeeper, this is zookeeper, and this one is server or broker. Okay. So both zookeeper is running, server or broker is running. Now let's start. Let's start Kafka tool. Kafka tool. So you can see Kafka tool. Type Kafka tool. Or offset explorer. Click on this offset explorer. Click on offset explorer. Yep. So I have already created some cluster connection. Let me remove this one too. Delete this one. Okay. So now go to file menu, add a new connection. Go to file menu, create a connection. Create a connection. So for this one, file menu, add a new connection. Add a new connection. When you click on add a new connection, here it is showing add cluster. In add cluster window, I am giving name is local Kafka. I am giving local Kafka. So cluster name. So it's give cluster name. Cluster name. Cluster name I am giving local Kafka. Local Kafka. So after that, Kafka cluster version. So here it is showing Kafka cluster version. So we have installed Kafka, right? We have installed Kafka. So which version of Kafka we have installed here? Did you remember, team? So Kafka version 2.0. Kafka 2.13, right? 2.13. Okay. So let me select Kafka version. So it's supporting 2.7. Let's select 2.7. Zookeeper is running in local machine and host name is localhost and port number of Zookeeper is 2181. Root path is /. Then click on ping. It is giving message saying server is listening. Okay. So next one, Kafka version. Kafka version. So 2.x. Next one, Zookeeper host. So I'm giving localhost, and Zookeeper port number, Zookeeper port
2181, then ping. Here you see ping. Then after that, if connection is successful, click on add. You can click on test also. You can click on test. You can click on add. So connection successful. Do you want to add this connection? So you have an option test. You have an option test and other one add. So click on yes, I want to add. So local connection is created. Local Kafka connection is created. Expand local Kafka. Expand local Kafka. Expand connection. Expand connection. Expand connection. So once we expand, right, here it is showing brokers, topics, consumers. Brokers, topics, consumers. Expand the topics. No brokers. Expand broker. Expand consumers. It is showing no broker running. It means broker may be stopped. So here it is giving error message due to warning stopped service logs. So Kafka logs. So let's see issue here. Let me restart server. So we have one broker active. So this is broker. Yes, sir. So this is the broker. Click on this topic, refresh. How many topics are there? 3. C family, JSON log data, user data. Okay. Yep. So this is offsets, consumer underscore offsets, C family, JSON data, user data. So let's click on this user data. See properties, click on data. So partitions, how many partitions created for this one? Configuration. Okay. Let's go this JSON log data. Here we have partitions. There is no data. Okay. Let's go user data. User data, refresh. 3 partitions are there. Partition 1, click on this data. There is no data. Partition 1 I am opening. Partition 1, let's see, is there any data? No. Let's say instead of oldest, newest also we are not writing anything. From specific offset, no. Let's go write a message into this Kafka topic. Okay. So to write messages, we go for producer. Yes or no? So Windows Kafka producer. Console producer. Kafka console producer. By using Kafka console producer, we can write messages into Kafka topic. Yes or no? So let me write it in. Let me open producer team. You can open in from anywhere. So let me start producer. You can execute this command from anywhere. So here I want to write a message into user data topic. User data topic. User data. Yeah, sorry. It's a command. Let's execute this one. So it is waiting for writing topic. I am writing welcome to Kafka tool test. So I return message into Kafka topic team. Before that, let's see. So here we got an error. Okay, let's refresh user data. Let's refresh the topics. User data partitions, partition 0 data. Let's go for C family. Let's say I want to create a topic. You can create topic here. Add a new topic. New topic name. I'm writing Kafka underscore tool. Partition count equal to 3. Replication factor count is 1. Then click on add. Kafka topic is created in Kafka underscore tool. Partitions. There is no data. So now let's write a message. Kafka underscore tool. Yes or no? Welcome to Kafka admin world. Message is successfully written into Kafka underscore tool. Let's see here. So let's go partitions, refresh. We have 3 partitions. Partition 0. So this is offset number. This is offset value. Let's go partition 1 data, partition 2 data. How many replicas are there? Only one. No duplicates, only one copy. So we have offset number. This is the value. There are no consumers. We have only one broker. We have only one broker. Currently, there are no consumers are consuming this data. Clear, right, team? How to see or how to create a connection between Kafka with the Kafka tool or offset explorer. Clear, right? Okay. So we seen only Kafka connection on single node, Kafka single node connection. Yes or no? Same way you can create a connection to any Kafka cluster. Only one thing, we give IP address. Okay. Previous session we seen Kafka single node connection. Yes or no? Now by using Kafka multi-node collection, we have already one zookeeper and 3 server or brokers. Yes or no? So we have a cluster. I am creating connection. Connection creation is same for single node or multi-node or any cloud. If your Kafka cluster is on any cloud, connection creation is same thing. Only one thing, start Kafka tool. Start Kafka tool. Kafka tool or offset management tool. So type Kafka tool. Kafka tool. Let's say offset explorer. Click on this offset explorer 2.0. Yep. So now I am creating team. So first, how can we create a connection? Here we can click on add new connection or go to file, add a new connection. So here, properties, zookeeper host. Tell me where is zookeeper? 192.168.0.101. Here we may get chances our zookeeper mission IP address is ping, but this port number may not be accessible because port numbers are not enabled. Let's check first. Ping is successful. So this mission is working, connection working correct. When we use port number, when we click on test, here, please enter valid name of the cluster. Okay, super. Multi-node cluster. Then click on test. It is trying to connect that zookeeper mission. Here we are going to get an error. We are going to get an error. Oh, connection is successful. Do you want to add this connection? Yes. So it is connected successfully. One important to note, team. One important to note. 2181 port. 2181 port is we have to enable. We have to enable 2181 port. Did you remember in prerequisites we have already enabled? Yes or no? We have already enabled, that's why it is working connection. Okay, so create a connection. After that, create a connection. Create a connection. Now let's understand multi-node cluster. Expand this multi-node cluster. We have created some topics. Let's expand the topics. Did we create any topics in multi-node? I think not yet we have created, right? We haven't created any topics. So brokers we have 3. 102, 103, 104. 3 brokers are available. Consumers, we did not try to connect to zookeeper mission. We did not try to connect to zookeeper mission. That's why it is not showing consumer details. Yes or no? We did not create any topic. That's why it is not showing any topics. So we successfully created multi-node cluster, and we successfully connected multi-node cluster by using offset explorer. Prior to offset explorer, prior name is Kafka tool. Okay, clear, right?